Okay. So one of the things we do it is we kind of record this session so you can hear it back also when you go home, so that like it's in conversation, you can recollect it and go back into that. Now let's talk a little bit about logistics as we go through it. So typically we go from 9 to 1 on Sundays, and this is like 7-session course.
We used to teach like in 3.5 weeks, but we are stretching it out because of some issues,
Logistics also, it becomes too much accelerated pace for the students, right? So we were trying to like space it out. So we do usually go from 9 to 1, like it's a lot of times. We may, depending on a small class size like this one, we may wrap it up around like it's 12:30, 12:45-ish. What you're gonna see it is mostly on the first session, we trying to set it up the context. So that's a lot of heavy lectures, but from second session onwards, it's more interactive session. So the more you prepare it from some of the homework and some of the sessions, the better it is in the conversation in the class. Okay. You wanna
Thursday
talk
evening.
about-
Thursday.
Yeah, so Thursday evening, typically at 6:30 to 8:30 is a session that we keep it for lab, right? So any homework activities or any of the questions that you may have it, we essentially like are there to address it. There is no new material we talk on Thursdays. The most of the material is only on the weekends, but it gives you an opportunity to connect it, talk through it, present your homework, so it allows us to continuously move through it. So as you go through the course, there's going to be a lot of reading, right? So it's kind of partial, and I tend to be a little bit old school in terms of the more homework type of things you do it, the more practice you do it, the better you get the knowledge and understanding of it. So that's where we're going to do it. Thursday's class is all online, not in person. We'll be on the same Zoom call. That's what we'll do it. Okay. Anything else in the logistics? We tend to take about a break after hour and a half-ish, so to 2 hours, to allow you to stretch the leg. We have a water fountain as well as we have restroom here in the class. But it's good to stretch it out after sitting for 2 hours.
Okay.
We'll talk about the
scheduling.
Yeah,
Let's talk about it briefly. So that go ahead.
So the week of 4th, 5th, 6th, gonna be out of town. So the question is, we can do either the next weekend or the following weekend, both Saturday, Sunday session, if that works for most of the people. That way, we don't have to stretch out the course beyond the normal plan.
Now, anybody working on Saturday? I just want to ask that, so if any of one of the student has issue, then we will not do that.
This is just for next Saturday?
One week.
One weekend, either next or the weekend after that, whatever works for everyone.
Whatever works for everyone.
So,
It's gonna be Saturday and Sunday.
right,
That's the only weekend.
So the next Saturday is scheduled for me.
It is
Okay.
good.
Yeah.
Okay,
no, she said,
you have scheduled, so.
Yes, yes, yeah. Mhm.
we won't do next Saturday, so we'll do the following Saturday, Sunday, which is,
28, 29, I think 29.
yeah, I think it's 29.
29 will not work for me.
Okay,
Okay.
so will the next Saturday will work or will not?
I mean, April 4 or 5. I'll just check.
That's the one we are trying to reschedule, right? That particular one. Anyway, if it doesn't work, then we'll stretch it out.
Yeah.
So we will
Yes,
have,
Sunday works better. So.
yeah.
Or
we'll
what
have
we can do is we can
yeah.
do some sessions on Thursday evenings. twice.
Let's
can
just,
say.
we can just stretch it out one more weekend.
Yeah.
That's perfectly fine with us.
Yes.
But
thank you.
then you guys will have a break, so that's the only thing.
Okay.
Yeah, okay,
All
no
right.
worries.
And if like, I have, like, I will be not there on 13th of February, so I will get the recording of this.
Yeah,
Yes,
that
yes,
will be recorded.
you'll be there, you will have a recording. We record all the sessions.
Okay.
All right. Ready?
Alright, good,
All right, so let's get started.
okay. All right, then we'll get started. Dilip
Where's the
will be
battery?
teaching today, so I'll be in the back.
So what we're gonna talk today, it's around the fundamentals, like I wanted to give a view in terms of what is software, how the software is built. And where does the business analysis fits into the overall software development cycle? Okay. So let's talk about the software first. Okay. So this is the definition of a software as defined in Wikipedia, right? It's essentially a set of machine readable instructions that tells the processor what to do next, right? And it's a little bit different from firmware, and in a moment we'll talk about what the firmware is. Okay. But think around software as a thing that powers most of the things that we utilize today. So if you're trying to do any personal task, right, all of you have smartphones, right? Whether you try to do an email, take a picture, send a picture, all of those things are nothing but a computer software, right? You do any Google search or any of the other search platform that utilizes do that. Harshil and I were just talking about the taxes, right? Most of you use some sort of tax preparation software to do that, right? Both of you mentioned like you have some exposure with the kids, right? And as well as online, both of you mentioned it. Kids play internet games, right? Adults play a lot of games, whether it's Xbox, PlayStation, all of those things. Nothing but a software. Okay. So anything that essentially helps you with some sort of productivity activity is currently done by software today, right? Think about not just any of the productivity, right? In fact, nowadays, all of even home appliances are smart appliances, right? It's connected to the internet, connects it to your home network. It's all of those things is nothing but a software. Okay. So when you think about it is a software, it's nothing but a sequence of instructions to do the things. Okay. So I'm gonna want you to think a little bit differently. When you think around a software, right? And when you think a box, right? So if you think around any computer or whether it's your phone or it's your laptop, your iPad, any of the devices that you think about, touch it, right? At the bottom line, you're gonna have something known as a hardware. Okay. So whenever I touch the phone and pick it, this is the hardware, right? It's things that you can touch and feel on. On top of it, there is a layer of software called a system software. A lot of you know that through a word called operating system, right? Whether it's an Android, iOS, MacBook, Windows, Chromebooks, right? All of them are system software. And on top of that, something known as an application software. Okay. So when anybody says that it's a computer, it essentially, or any device is a computing device, it essentially contains this three part. Okay. The bottom two part, a lot of times you will hear word platform. People will say, what platform your software is running on, right? It's essentially a hardware and OS, right? So when you say it's a MacBook or Mac OS or Windows OS or Linux, all of that is known as a platform. Okay. And the way things works is a hardware has a tiny bit of software known as a firmware. Okay. So let's say you want to send an email to somebody or want to make a phone call. Okay. what are you gonna do? You're gonna first pick an app on your phone, right? And then you're gonna go ahead and type that email. What happens is at that point, whenever you type an email, that application software essentially sends information to the system software using something known as an API or a system calls and tells it, hey, here is the email. It needs to be sent to this address and it needs to have this content. Okay. That system software then takes that, converts into operating system calls, and through firmware that sends it to the hardware. Okay. At that point, hardware is nothing but it takes that particular call, encrypts that, and sends it into bits and bytes over the wireless. Or if you're it's connecting to a network on a laptop, it'll send it through the Ethernet cable. Okay, so that's where the communication goes. Whenever something is coming in, it first comes into hardware. Hardware essentially converts that and informs that to system OS, hey, I got this message, which in turn converts that into application software. Okay, so that's how, in a nutshell, the operating system and the application software works. Most of you, I would say it's about 99.9% time, when people talk about us doing a business analysis or building a software, they're talking about building an application software. Okay. Very, very few people build an operating system level software. Now, this could be true not only just on the portable devices that you're talking about, whether it's a MacBook, Windows machine, or phone, right? But a lot of times when you're talking about building into specific hardware things, like it's your nowadays, a lot of thing is automated cars, right? Tesla coming into it, like it's Hyundai, all of those things, they all contain software, right? And that is always going to be some application software and some system OS. Only difference is that system OS is not Windows or Mac based, it's specific to that. Okay. Any question in terms of understanding what software means and how it fits into the picture?
Yeah, no question is a stupid question, right? So feel free to ask, okay? I mean, this needs to be interactive. Any terminology you don't understand,
Yeah.
please ask, okay?
Okay. So, system software, right? So this is something that it's the middle layer that we talked about, operating system, right? It's essentially, its function is to coordinate between the hardware and then application software. Okay, a lot of times, as I mentioned, they talk about platform as a combination of hardware and system software. The next aspect is application software, right? So this software is specifically designed to help with the productivity type of activity or any of the gaming or search type of activity. So think about it. It is a software that is not required to run your phone or your MacBook, but it's something that you build it or added on top of it after the basic components or platform is built, right? So in the olden days, things used to come with a flash disks, optical disk, right? So USB drive or CD-ROM or DVD-ROM, right? Or a lot of times people just download it into a hard drive. But most of the days now, it's pretty much everything is downloaded from the internet, right? So this is the thing that you downloaded from internet, right? An app you download from App Store. Okay. So its primary function is to essentially enable productivity, right? And it could be as simple as the PowerPoint that I'm using, right? All it does is just allows you to communicate it, present it so that its productivity of sharing the information can be improved. Okay. They essentially interact with the system software and then which in turn allows it to perform whatever task needs to be done. So think about when you're doing a gaming software and you're doing a controller. From a controller, you're just giving a directions that gets, it's a hardware, right? It gets converted into whatever the game that you're playing it. It says, hey, if I'm just kind of moving a person left, right, I may be just using that keywords or jump. All of those activity that you indicated through the hardware gets transferred into the software. And that part of it, that's where the application software interacts with the operating system to do that. Okay. Now, when you think about application software, you can categorize them into three different categories. One is proprietary software, which is essentially built and owned by a specific company. Okay. You can't just take it and use it the way you want it. You have to have a license, but more importantly, even than license, right? It is built and own everything by it. Typically, they don't let people to do the licensing type of things, right? So I think about when you're doing it, when I'm driving a Tesla, or when I'm driving an Ioniq, right? And nowadays in most of the cars, right, you have lane assist type of functionality. All of those things you're doing, it's a proprietary, right? You can't take that software. It has embedded in it and it's owned by the company itself. Right? Then the second aspect is off-the-shelf software. Okay. This is what you essentially go ahead and purchase it from the shelf. So this is where the licensing comes in, right? So, hey, I want to, like, let's go buy a Microsoft Office, or I want to go ahead and buy a TurboTax software or a HNR software, right? All of those are off the shelf. The difference between proprietary and off the shelf software is proprietary software tends to run only on a single type of hardware. Okay, so that's why I gave the example of the car. You can't just take that and put it into a Honda car and expect that to work in the lane assist the same way. Okay, another example is like I'm much more into the space and science, right? So whenever you like, it's kind of powering a rocket, right? It's a specific software built for that rocket only. It's not, you can pick it up and put it into the other rocket. Versus off-the-shelf software, it's typically kind of supported over a wide range of computer platforms. That you just buy it for appropriate platform and then install it, but it behaves and functions the same way across multiple platforms. Okay. The last part of it is an open source software. So when you talk about open source, it is essentially a software which is built by community for the community. Okay. It's a difference between the first two. First two, you have to pay the money to use it. The open source software, you don't have to pay the money. It's essentially used for free, as long as you follow certain rules. Okay, so there is what a lot of times known as end user license agreement that you have to sign up from an open source and do that. So think about it, open source software as Android operating system. Even though Google built it, it kind of put it in an open source community. You can actually take it and install it in any device that you feel it is going to be compatible, and you can customize it. Okay. Another open source software that you're going to hear a lot more is the Unix operating system. That is what powers majority of, I would say, is the enterprise application and enterprise servers. All of those things are open source. Okay. Another angle that you want to think about it is, even though open source software is free, people build services on top of it. And then they charge for those services. So software itself is free, but then additional enhancements that people can do it that can be charged against it. So most of the software that you're going to build it, if you go into a company like Nationwide or JP Morgan or Limited, locally here in Columbus, right? All of that you're going to do it is build a proprietary software. So the way you want to think about proprietary software, it's not something that is runs only on a specific hardware, but it is also owned by a company. And it's not going to be used outside the company other than serving the customers or the employees of those companies. But if you're building some sort of a game, let's say you go and like it's work for a company which is building software games, right? Like EA Arts or that, like something like that. Then you were building off the shelf software. Okay. So just depending on type of work that you do it, you're going to be in the first to run. I've not seen many people building open software who are at the entry level, right? It's a lot of big corporations who build it, like Java is an operating system, which is an open source, right? Some of those things. So when you are getting into the work field, most likely you're going to be in the building the first two type of software. Okay. Any questions before I move into next segment? Okay. So we talked about how the basic fundamental, what is the software and how does it, right? Now let's talk about how do you build it. Okay. So just like anything that you try to build it, first thing you need to think around architecture around it, right? So this is the Wikipedia's definition of architecture. But think about whenever you talk about architecture, it's nothing but it's a high level organization of structures that you do it that essentially tells it how they interact with each other, what are the bounds of those structures are, and what is the relationship between them. Okay. So the moment we talk about architecture, right, things comes around the buildings, right? Whether it's a building of bridges or building of houses and that, right? So when you think about building a bridge, right? Every element within that bridge has specific relationship and specific roles, right? Including if you need to put a bolt, right? That bolt essentially is designed to do a specific load, specific function on it, right? Same way, that's what happens even with the software architecture. When you're building a software, right, there are components that you're building it, and then you need to think about what is the relationship going to be on those components. Okay. So software was originally built, started getting developed. It's in, I would say, it's mid 1930s. Right, so it's about almost getting it to a 100-year life cycle. Right? So if you notice it same way, think around bridges and houses that human has been building it, right? Over 5,000 years, how those things has evolved. You still see the different types of bridges. Same way it's going to be in a software, right? So over the 90 odd years, there are many things that's built in software, right? And there are different architectures that are used to build it. Okay. Part of the reason why we wanted you to understand the architectures is because as you go into the requirements, you really need to understand what is the intent and how they're going to intend to build it, right? The business solutions. And then there is also going to be a system specification. So those two bridges it, that's why the architecture comes in. So having a basic knowledge of what are the different types of architecture, it's going to help you to essentially understand it as how you're going to go about requirements. So the first type of architecture that was originally when the computer started coming around was a monolithic. Okay. So whenever you talk about a software application, remember I said it's nothing but a set of instructions given to a machine to do that. But any instructions comes along with the data, right? So whenever you look for software, there is two components of it. One is the data and one is the instructions. Instruction operates on the data in order to make a sense of that data or make a valid values out of those data. That's what that is. So monolithic apps are essentially where code and data closely coincides. Right? You can't separate them. Once you set the data, once you set the code, it is going to go with that. Right? You're going to see this lot of these things into a autonomous space objects, right? So whenever you like, it's kind of trying to fly, right? Specifically, when you're trying to send something to Mars, the communication lag is 8 minutes, right? You can't wait it for 8 minutes. So everything has to be essentially integrated right in there in this rocket itself. That's what the monolithic code is. Another aspect is it's a big, as I say, science guy, like it's I watch science movies. Has anybody watched a movie called Enigma? Okay, so Enigma is a movie, was made it of during the Second World War timeframe. So Germans had a lot of U-boats and they were essentially sinking a lot of Allied ships. And all of those communications were happening through encrypted messages. So Allied forces were trying to figured it out how to take that message and decrypt it enough in a time to take an action around it. So that movie is about the original computer was built by a guy called Alan Turing. He was a British scientist. And he was building a mechanical computer where you can provide the message, coded message, and then go through it and decipher the message, right? That's a perfect example of monolithic because you had to actually take the message and put it as a mechanical levers within the machine in order for it to do it. So they were putting the data as part of the machine itself and then crunching that in order to do that. So that is a perfect example. And that was one of the original computer that was built in 1930s. Then as things evolved people realized that it's in the 1930s, when you talk about computer, it was multiple floors in a building. Right? It was not things like what we see it today, right? Today, this one has actually more power than Apollo 11 mission that went to the moon. Okay. But they started thinking about making so much investment on a computer and can be used only if you are in the building. That's not most effective use of it, right? Specifically for the corporations. So they started evolving architecture of the computers and it started coming into what is known as client server architecture. Okay. In this scenario, the computing horsepower is still centered in the servers. Oh, now we can say. So computing power is still centered in the server, but most of the times it's just waiting for the instructions to come, right? It computes pretty quickly compared to the input that comes in. So they started breaking and says, what if we kind of multiplex it and then it's have multiple people give the instruction? Okay, so they started building a client, right? Every client sends a request to the server and gets a response. Now, as you do these things, it becomes a complex thing, right? So if I'm a business analyst, right? In this example, it's fairly easy. You just give the input, what input you're going to give it as a data, and what is the output you want it. It's as simple as that. But as you get into the client server architecture, now you have to think it a little bit differently. It's not only what input you're going to get in, what data you're going to get it, but you need to start thinking about, hey, what happens if I send you a request? How can you guarantee that I'm the only one who's going to get the response? Think about most of the early computers were an insurance company and a banking company. If I ask you to deposit a money, how do I make sure that it's depositing in my account and not somebody else's account?
Account number, specific account number.
Right, but then that is a guarantee, right? So that is, as a business analyst, now you need to start asking those questions. When you send a deposit, well, what needs it? What information you need to send it to ensure that it gets in the right place? What happens if I send you a request and I lose my network connectivity? And you're trying to say, how do I know that it got deposited? Or how do I want to make sure you didn't send my response to on client 3, right? I'm not sure why it is. Still have an issue with the pen. No, I'm trying. Could be. But essentially, that's the complexity that you need to start thinking about it, right? Sure, your computer system became a little bit more flexible, but it also became a little bit more complicated, right? And you as a business analyst now need to start thinking about, hey, what questions I will ask it for so that I get the holistic view of what needs to be built. Okay. Then early 70s, mid 70s came in, right? And people started thinking about utilizing it information a little bit differently because now they started collecting the data, right? And in any big companies or nowadays, and even in a small company, what is the biggest intellectual assets? It's the data, right? So you need to start thinking about utilizing data differently. But now when you start utilizing data differently, that means you can build multiple things on top of it. Different applications using the same data. Think around some sort of personalization starts coming into the play, right? So the architecture got evolved and then says, okay, we're going to break it into 3 tiers instead of just a client server. We're going to encapsulate the data because we need to protect that significantly. And that's becoming a larger and larger component, right? Because now they started getting into millions of customers, right? So the data becomes its own place to where you have to worry about managing, right? That's why your database management systems started evolving into it. You still have a business logic that you need to build on top of those data to essentially provide a value on that data, right? Whether if you're like, think about you're in a bank, right? Your data is all of customers' data, customers' deposits, customers' assets. The application here is around what products they use in it, right? How they interact with all of their deposits. And then the presentation tier started becoming it with the, what they call it is a thin client server, where you're taking the information, but then you're presenting into different form factors, right? So for example, like it's in a banking in early days, if you walk into the branch, right? Only some of us has walked in, not all of us. Like none of my kids really go to the EC at the terminals. But I still do it because I work at the bank. Think around it in the early days, there used to be green terminals. That if you walk into the bank, the teller will have a different view. Versus if you're trying to access from a home, even now today, if you walk in at Taylor is going to have a different view than when you walk in at home. If you go to ATM machine, the same account, right? You're still doing the same deposit, but you have a different view presentation, right? So that's where the 3-tier application started coming into it. And as with anything else, right? The complexity increases it. You need to start thinking about it as, hey, who is the persona for which this information is going to be present? Is it going to be Taylor? Is it going to be an employee? Is it going to be some customers? What all they can do with it, right? Because obviously Taylor can access anybody's account to it, but you can't access anybody's account. You can access only your account, right? So there comes a different requirements that you need to think about. Who is accessing it? What kind of restriction we need to put in place? Then the internet started coming into play, late 90s, right? So things like originally, for those who were around, the Netscape started coming into it. The likes of AOL started coming into it, where you have lots of customers, right? The Google started searching coming in, and then companies like Amazon started coming into the play. Okay, so think about the 3-tier architecture, right? You have one machine, one application, right? It's easy to handle it if you're like, it's have 1,000 customers or 5,000 customers. when you get into the millions of customers trying to access at the same time, you need to start thinking about, is it sufficient to have it a horsepower to actually give them a sub-second responses? Right? So that's when the newer architecture started coming out and they said, hey, what if we take the data layer and then actually break it into two? One is persistent and other one is in the memory. Because the memory is always faster than the persistent. And then what you do it is presentation layer also now, because of the thin phones that, because in the late 90s, you started getting what we used to call a brick, which is a heavy cell phone, but you could still touch it. BlackBerries and started doing it, right? And then like as you started seeing it, iPhone started emerging it. So your presentation layer is going to be different because your form factors are not continuously changing. So you need to start thinking about breaking it into two different. So this is the architecture started getting adopted late 2000, early 2000, late 1990s, early 2000s is when this started taking a predominance into it. Okay. Let me see if this still works. Oh, it works on this one. So I want you to think about it. When you talk about those architecture, there are a few fundamental things that you need to think around it, right? So when you buy a computer, right, you have,
If you are still showing the multi-tier application.
oh, I'm still,
Yeah. So the online folks cannot see it.
let me see if when I shared it, did I share the whole desktop?
Yeah.
I shared the screen. That's all I need, right? Yeah, are you able to see it now?
Yeah, now they can see.
Okay.
Yeah.
Yeah, not video panel. Floating. Okay. So even online, if you have any questions, feel free to stop me and say, raise the questions, okay? So when you think around computer, when you buy something from, let's say, a Micro Center or a Best Buy, right? So things that will have it is it'll say it's what type of CPU it has it, right? So it'll say it's, if you're buying a MacBook, it'll say it's an M4 or M3 type of CPU. If you're buying Windows, it'll tell you like it's an Intel or AMD type of software. I'm sorry, it's type of CPU. Along with that CPU, right, you will also see it, well, they will say it is, what is the level 2 cache, right? It'll be like it's a 1 meg, 2 megs, or like 16 meg type of things, right? So they have an L2 cache. Okay, so whenever computer performs any instructions, they usually get it from this L2 cache. And this L2 cache is essentially built within the CPU itself. So it's very fast, right? It's kind of just handing off communication, right? If you're standing somebody next, you're doing it. That exchange is very fast. Okay. So a lot of times it happens into really seconds, right? So 10 raised to minus 9 seconds. That's very fast, instant. Okay. Then they have something known as read-only, random access memory. Okay. So when you buy a computer, it will also tell you, hey, along with this, it's a 16 gig RAM, right? So the difference between this and L2 memory is that this RAM is still on the same motherboard, but it's not within the chip itself, right? So it's a little bit farther away. It needs to go out from a chip, go into the motherboard circuitry, get that. So think about it. If you're telling a kid to get something from their classmates, they're sitting right next to them, right? They will get it very quickly. But if you tell them, hey, get something from the main office, the principal's office, which is still in the same building, right? They need to go walk out, get that, walk back in and give it to the teacher, right? It's gonna take a time, right? Because it's gonna go traverse it. Right? And me handing off it's faster than me walking around all the way to the end of the building, getting it and giving, right? So this memory is kind of a little bit slower. This typically is in 1,000 times slower. Okay, so when you go L2 through RAM, you're dropping it by 1,000 times. But again, everything on the CPU goes it from only here, right? So you have to, any instructions the computer has to take it. Even if it's stored in RAM, it has to first come to L2 and then get into them. Then you will have something known as a hard disk, right? So you get some 512 or 1 terabyte SSD drive. That is not embedded on the circuit board itself. It is something which is connected through some sort of cables onto the circuit board, right? So it's in a hard drive, right? So this typically, it's between 10 raised to 4 to 10 raised to -3, right? So this goes into the millisecond type of thing. Okay. Anything that you're trying to access it has to go first from hard disk to RAM to L2 to get into it. Okay. Here also, nowadays, most of them is a solid state drive, right? But those who still have a little bit older computer, you have the spinning disk, right? Magnetic hard drive, which is a little bit slower. It's usually in the matter of 100 milliseconds. Then, a lot of times, for those who still kind of use it, whether the flash drive or CD-ROMs or DVD drives, right? It can contain a lot of additional data. Now you can get an optical drive, which is significantly big storage. But from there, it needs to go to the RAM. So it typically goes into the RAM, but these are typically in 10 raised to -2 space. Okay. And then the final tier is a lot of times you just kind of store it into the flash drive and keep it offline. And if you need to access any data which is offline, first you have to request somebody to put that on online and then access it, right? So it becomes an offline. Now, if you look at it, right, from a CPU to offline, things get significantly slower. So the question is, why even bother offline? Why not keep everything into L2 cache? Right? From a business point of view, when you think about L2 cache, it costs you about $100 per meg. So if you want to, like, it's a huge amount of data, it's going to be very expensive. Also, there is an architectural limit. It's like you will hear about something like 32-bit or 64-bit. So you can do it only that much. Anything after that, the CPU cannot address that directly. If you go to the RAM, it's about $10. This is about $1 a gig. This is now in sort of pennies a gig. So if you're a big corporation with millions of customers, think about where majority of your data is going to lie. It's going to be lying either this tier or this tier, right? And then, but you need to pull it when it's needed. So that's why I kind of showed you this architecture. Okay, so think about this way, right? This is the database, probably $1 per gig type of things. Stores a lot of data. But when I have millions of customers, taking it this, it's going to take a significant time to do it, right? But if you go to Amazon, it picks it up very quickly. Right? So what they do is in this architecture, they take it information and says, okay, I'm going to keep all of the active customers into memory. Anybody who is not active will stay in there. As soon as somebody logs in, I'll bring their profile and information in here till they finish their transaction, and then I'll move it back in here. And then anybody who is no longer active, I'll take it out, put it up here. allows me to take a faster access time. So if you notice it, right, any of the, like it's even whether it's an Amazon or anything, the first time you log in, it'll take a fraction a little bit more. Right? What is happening is it is kind of pulling their profile and bringing it into the member. Right? Because even after the millions of customers, you're probably going to have only few, like it's less than 10% active at the same time. Right? We all are most likely Amazon customers. We don't log in all the time, right? We log in only when we really need to buy something. The most impactful effect you see it is on a Black Friday, right?
Yeah.
When there are more than expected people logs in, that is a constantly happening, or there is no more enough room to bring it. So this one takes a little bit longer time, so you can start seeing it, things buffering. Okay. Same thing, so that was the data layer to break it down. And then UI layer, the same thing, whether I'm accessing from my phone versus accessing from my laptop, it's gonna be two different, but it's still, the presentation is still the same. Now, from an architect, business analyst point of view, now you need to start thinking about asking questions. What all type of interface they're gonna do? Are they gonna access from phone? Are they gonna access only from laptop? Or do you have to be in the building? You can access remotely. What is it's gonna be? Depending on that, you need to ask what information is gonna be presented. If it's a small screen, should everything be presented to them, or only a subset should be presented to them? Right? So all of those things starts coming into understanding your requirements. What exactly I need to do it now? Same thing. You should ask it, like, what is the response time from here versus what should be the response time if that's here? How long they should keep it? What logic you should use it to keep it there? All of those things comes into the play. Okay. Then the internet came in significantly. So now people started providing a services that is not confined within your own company domain. So think around when you go to buy something from Amazon, right? In the early days, right? Amazon is now a little different. They have their own logistics and transportation stuff. But in early days, right? When you go and you buy something from Amazon, Amazon doesn't own the bank. So your payment needs to go to somebody else. But once its payment is done, when the shipment happens, somebody else, like it with the FedEx, UPS, or United States Postal Service carries the for them. So I need to make sure I interact with those different companies to give you the status, right? Because you don't go to FedEx to check your status for your Amazon order, right? You go to the Amazon website and say, show me where, track my order, where is it? That means now I need to play it with the other service providers to build it together and give it a singular view when I'm buying an item from an Amazon, right? So think around how it works. When you go to the Amazon's website, right, you just get presented with the information, right? And then at that point, you can say, hey, I'm going to browse it, the product that I'm looking. I'm going to search. First thing I'm going to search, right? Because if you think around what is the logic, you search, browse, add to the cart, purchase it, and track it, right? That's the normal sequence. So that is an orchestration. Think about it. Every time you do it, the Amazon is orchestrating your order to take you through those steps, right? So you're going to have an orchestration layer right underneath the presentation that guides you through those different functions. Underneath that, you're going to have a service layer, right? And there is going to be different services. So first service could be is, hey, when I'm like, it's kind of searching it, it's going to give you not all the details, right? It gives you a small snippet of everything that it's available to you. Right? Let's say if I'm like, it's searching for a pen, right? It'll give you, and when I say, hey, give me a pen, it'll give me probably 1,000 list, but not detail. It'll give you a picture, a small image, and then so on, right? So that's a service layer, it's a search service. Then I may have said, hey, I want to look at that pen in detail. So I click on that. At that point, it's going to use the different service, right? Give me the product details. I want to see everything product details, what the rating is, what is the cost, is there any discount, is there any images associated with it, what is the spec specification for that particular product? Then underneath that, where does it go? Those products rely on some database, right, within the system. So I'm gonna go ahead and pull that product from there. But underneath that, there is a huge system, right? Like it's the banks specifically. They're not rewriting every time a new architecture comes. Believe it or not, 99% of your core financial transactions still runs on a mainframe today. Even though like it's people think about, hey, mainframe doesn't exist. Anything that you send your money across any governmental entity all runs on a mainframe today. Okay. And it's not a significant, like the project that I'm kind of part of it right now, it's multi-year projects to overhaul, getting away from mainframe, getting into the cloud. Hopefully it'll happen before I retire, but the amount of the knowledge, amount of the application is built into that, including the ERP, right? Your oracles of the houses, your SAPs of the house, which performs all of those purchases, inventory management. You don't see it when you go to the Amazon, right? It's happening on the bottom layer, but all of that information is available to you. Same way, like it's if I'm doing it a payment, right? Amazon connects that to the gateway, to either the Visa, MasterCard, or any other payment processing gateway. And then at present, what is it present? Here's your credit card, here's the information about the customer who's trying to buy it. Here is the amount that they're looking at it. Do you authorize that amount? Right? That's what it does. Now think about it as a requirement. You need to think about what information I'm going to send it, what information I'm going to get it. Right? Sometimes your payment gets rejected. Whatever that gateway, right? It just says it rejected. How do I deal with that? Right? All of those things comes into the play. So service-oriented architecture essentially enable you to go across the boundaries of the corporation to encapsulate and provide a service that may involve more than one corporation. Right? You're going to run into those kind of requirements and architectures as you go through it. Right? So as an analyst, you need to really understand what kind of questions I'm supposed to ask it in order to get into that aspect. And then 2007, 2008 came in and Mr. Jobs revolutionized by making access to the mobile devices easier and intuitive, right? There were phones before it, right? Blackberries and everything, but it was not very user-friendly. With the touchscreen, with the iOS, iPhone, and the Android phone, it becomes an easier. So more and more people are using tablets and the phone to do most of their work, right? But think about it, if I'm like it's driving it in a remote Midwest highways, right? I may not get the full connection, right? I may have a spotty connection to the. So when I'm sending an email and I don't have connections, I can still type or write email, keep it, right? As soon as I connect it, and then I will send it to them. But that requires me to now keep a track of when did I send it last time. Specifically, if I'm doing any financial transaction, I don't want it to be done 5 times. Every time my spotty connection connects it back, right? So you need to start thinking about how you're going to architect the mobile applications. There's going to be a local copy. And then when you connect to the internet, then it's a remote copy. Remote, it's still going to be all of the multi-tier architecture or service-oriented architecture as the corporations or the banks offer it. Right? And then it still gives you, hey, give me a sync to the last time. It keeps a local copy. Right? So it's specifically like a perfect example is the email, right? When you're connected, it'll like sync it and give you all of the latest emails, but it'll not give you everything. It'll give you from the last time you connected it. And from last time you connected, whatever email you write it, it'll synchronize and it'll send it out. Right? But then as an analyst, now I need to start thinking about different things. What is the online, offline experience is going to be? What should be the sync point? What should be the sync logic? You need to ask all those questions in order to understand before they can build that application. So. Any questions? Understand all of those things? So as you go through it, building it, what kind of questions you need to start thinking about and asking it, right? So that's why it's important to understand what are things you need to think about, how things works behind the scenes. Now, things we're going to talk about is the software development lifecycle. And you mentioned it that you had to interact with everybody in the different software lifecycles, right? So think around the way I kind of think around software is in terms of analogies. So when you're building a house, right, it goes through a specific life cycle of things. Right? So think about it. If I'm building a house, what is the first thing I'm going to do? No, that's happens too late, way later in the cycle. Even before requirements, right? First, I'm going to make a decision around, do I really need to build a house or can I just rent a house? Right? What is my requirements of why I want to build a house? Right? Is there a justification, right? So if I'm going to be visiting somewhere only for, let's say, 3 weeks, I'm not going to look for buying a house, right? I'm going to look for renting there. Right? But if I'm going to be staying somewhere for 20 years, then I'm going to start thinking about it. Maybe instead of renting it, it's much more financial sense to build a house. Right? So first step it's going to be is a determination. Do I really need it? And if I need it, what problem it's going to solve it? Right? And based on that, I'm going to make a decision. Should I go forward or should I stay? Okay. Same thing in a software development world. Even before you build it, do I really need to build a software? What value it's going to add, what problem it's going to solve it, right? That the first step happens on the determination. Then, once I determine, hey, I really want to build a house, and what thing comes into it? Requirements, right? What kind of house I want to buy? Do I want to buy something in downtown? Do I want to buy it in a countryside? Do you want to buy it in suburbs? What should it be? Should it be a single floor? Should it be multi-floor? Is it a multi-unit, single unit? All of those requirements comes in how big it needs to be. It's like 2-bedroom, 3-bedroom, 4-bedroom. Like, should it have a basement? Should it have a patio? Should it have a backyard? All of those things comes in a requirements, right? So you decide what kind of requirements you have. Okay. Then the next step is you go pick an architect and says, okay, I want to get this kind of house, this requirements. Can you build an architecture plan for it? Right? So architect builds the plan. You go through the county approval, whatever is needed. Then you hire a contractor and says, okay, here is my approved plan. I want you to go build it for me. Right? So they build it. So that goes into construction mode, right? Takes whatever the time they need to take it. Then, once they are finished building it, you're not just going to walk in and start staying it, right? You want a county official to come in and make sure it's built according to the code, right? Your plumbing system works fine, your electrical system works fine, right? Your structural systems are sound. So if it's a multi-story house and your kids are jumping on the second floor, the last thing you wanted is it's kind of weak and it comes down, right? You look at all those things when you do that.
Yeah.
Right? So that's typically a testing phase, right? So a validation phase. I'm making it sure it meets it, right? But if I turn on switch and none of the lights turns on, do you want to move in? Do you want to pay for that house? Most likely not, right? You're going to ask them to fix it back, right? So there's going to be back and forth. You're going to do testing, or even county auditor does the testing and says, is it built according to the code? Yes, no, right? And then they're going to make the changes so that it complies to the code or complies to the requirement. And then once it's done, then you accept it. Once you accept it, what happens? You move in. Then you start thinking around the maintenance, usual maintenance, right? Light bulb gone, I need to replace the light bulb, right? The filter needs to be changed into the HVAC systems every so often. All of those things becomes part of your maintenance. But then at some point you may decide, hey, I have this nice backyard. Let me build a deck on it or a patio on it, right? So you build an enhancements or build a project on it, right? And that project has its own life cycle and same thing, right? And at some point you decide, hey, I'm done. I no longer need that house. I'm gonna move out and sell the house. Right? That's a life cycle, or you just longer that and says, okay, it's not structural stable, it's 100 years. It's time to get it out and get over. Software goes through the same life cycle. Okay. So think around the first phase, right? It's a planning. Do I really need the software? Right? And if there is a business justification, then it says, yes, I need to build the software. Great. Let's go through it and just say, what kind of software you need it? What should be the behavior? What should be the analytics? Right? So they put all of those things into as part of your analysis. Once you finish the analysis, then the design phase comes into life cycle. How I'm going to design it. Now that I know it needs to perform all these functions, right? Starts going back into the architectures, right? Based on this requirement, what kind of architecture I need to select it? Do I need to go a monolith, or do I need to go a full-fledged mobile architecture, or somewhere in between? Right? So that becomes part of your design. Once it's designed, then you start writing the coding for it. Right? You build it like it's if I'm doing it, let's say an online bookshop, right? The code is, hey, I'm gonna, like it's connect to the payment gateway. Let me just write a code to connect to the payment gateway, accept the payment, connect me to, let's say, FedEx system to allow it to ship it, write the code, give them the shipping material and all of those information about the products. So all of those things becomes part of your implementation code. And then as I talked about, like it's even within a house, right? As it builds it, you'll test it. Hey, it doesn't meet this requirement. You need to go back and fix it. They will go fix that different. Redo it. You go back, come back to it. You retest it. Right? You keep going in this cycle to a point where you understand it, that now it meets the requirement of what I'm looking for it in that software. And at that point, they shift it and says, okay, now we graduate from requirements or in the development to an acceptance, where you're going to take it and put it into production. Okay. Once it gets in, people can start utilizing it. Occasionally, there's going to be maintenance. You're going to find a bug, you're going to fix it and do that. And then goes in, right? So let's walk through an example, right? So if you're doing a tax, right? Tax software is not a simple thing, right? It's complicated. There's the state laws, there is federal laws, there is city laws, right? And based on all of those things, you need to build a software. So you come as a company and say, is it worth it for me to build a new software that enables people tax, right? I'm going to live in competition with TurboTax, HNR, World, a whole bunch of other things comes into it. Okay. You do the analysis, identify what all laws you need to do it, what all states you need to deal with it. And then you build a design. You implement. As you implement, you keep testing. Right? At some point you say it is working as expected. You ship it into customers, right? So now it's available on shelf, you can buy it. Once you buy it, they realize, hey, we forgot this particular item, so this particular deduction. So they're going to provide a patch. They're going to give you a maintenance, right? So your maintenance is not only just, hey, can I fix the software, but I'm also how I'm going to put it into production environment. How I'm going to give it to the customer, right? And then at some point you say, okay, this year's tax is done. Next year's laws are going to be a little bit different because Congress keeps changing things every year. So I need to go back and do that. At that point, I'm going to go into the next version of iteration plan. Some laws are the same, so I don't need to change that part of the code, but I need to update this part of the code. You had a question?
Yeah, no, can you touch a little bit on the team composition, for the SDLC, like, business analysts, PMs, and I'm not sure if everybody understands,
So I'm gonna do that as part of the waterfall and all of those exercises, so let's hold on to that.
Yeah.
Okay, so. Any questions in terms of SDLC? Okay, let's do one thing, it's weird, like it's an hour and 15 minutes into it. This is a good time to take like it's 10-minute break. Let's take a 10-minute break. And then for those online, it's 10:15, we'll start back at 10:25 with the software development methodology. Okay. So feel free to stretch your legs as you go through it, Let me put this in the pause.
can you check?
Yeah, Kaushal, let me see, it's on the video. Let me hide this. Are you guys back? Kushal?
Yes.
Yes, I'm here.
All right, let's get started then. Okay, any questions so far before I dive into software development methodologies? All right. So let's get into the software development methodology. So again, as I mentioned, I'm pretty big in terms of comparison. It's easy for me to grasp the concept. So when you think about when you're building a house, let's say I want to build a new house. If I go to 3 different builders, do you think they all 3 will build the same way? They will have their own reasons, their own ways to go about building it and build it, right? There's going to be finite number, right? There's like 4 or 5 different variations, not many. Same thing in the software development world. Depending on how you want to build it, right? There are 3 dominant software development methodologies. The first one is known as a waterfall. Second one is known as an XP or Agile. XP stands for extreme programming, right? But the Agile has different flavors of it. You're going to hear it as we go through it. Some may say Scrum, some may say it's Kanban, some may say it's extreme programming. But essentially what it is, it's essentially Agile methodology. And the third one is known as a rational unified process or RUP, right? This is typically used when you're doing a large scale programs, right? Like it's building a new aircraft or building a new rocket systems, those kind of large scale things that you do at rational unified process. Okay. So a lot of things you can see here, like it's compared to Agile, waterfall and RUP process are a lot of times people say it is a big upfront design. So you do a big design first before doing any actual software development. Versus in Agile, you do an incremental. Okay, so let's look into each one of them as we go through it. Okay, so first one is an Agile development methodology. So in this scenario, what you take it is you take a problem and break it into a small piece and try to solve only a small piece at a time and build on top of it. Okay. And then within that small piece, you still do full SDLC cycles, right? You still do it like it's kind of a design, a requirement analysis, design analysis, then you go implementation, testing, essentially hardening, and then deploy it into production and then do that. Okay. So that's how approach works it for every slice. But the most important thing in Agile development methodology when you're building it is essentially the vision. Okay. So as you go into most of the newer software development, right, what you're going to start hearing a word is more around not a project management, but more a product management. Right. So a lot of companies, as they're building its new mindsets and things, they're like it's terming everything around the product, and there is something known as product operating model. One of the big thing in that product operating model is having a vision. What exactly you want to build it and how you want to build it about, right? What is the purpose of that? So let's take an example of the software that we talked about for tax calculation. Okay, so think about it as I need to build a software that enables people's federal tax returns and state tax returns. Okay, that's my vision that I want to build and enable on it. Now, as you know, like there's 50 states, each state has different laws. On top of its complex federal laws, right? If you think about it, like it's if you're trying to look at it and say, hey, what are the tax laws? They'll give you like it's kind of 400 plus publications, says, here is all. Some are applicable to you, some are not applicable to you. So when they want to sell a software to you, which allows to perform the tax calculation, they have to implement all of that, and then they can give it to you. Right? Otherwise, they can't sell you for everything because they don't know what they even need, right? So, but it takes years, right? So sometimes like it's 3-4 years to build the first version of that, right? So think about it. If you're building a software for first version, right? You need it like it's at a minimum, right? Who all you need, right? You need people who are writing the software, right? Known as a coder, right? That's what the people's mindset goes in. And when you build a software, who is writing software? Coders, right? But it's not only the coders that you need to think about it, right? You need to think about, sorry. If you think about building a large software, it's not going to be only one person writing the code, right? You will probably have 100, 200 people writing the code. But then you need to make sure how is the work is divided among them when they work on it, how they do it, right? So you need a coder, but then you need somebody to manage all of them, right? So you need some sort of a program managers. But you also need it like it's, hey, when they build it, you need to test it, right? Is it working the way it's expected? So you need some testers. Then you will also need, hey, what exactly you need to build it, right? Because somebody gives you like its founded publication and says, okay, this is what your requirements are. It's not easy to understand, right? Somebody needs to kind of take that information and start compiling into the requirements. That's your business analysis, right? Asking, hey, what should I do in this scenario? What should I, just like I said, the mom indicator like this. You want to go this? Where do you want to go there? What are you going to eat at, right? What time are you going to be back? Who all is going to be with you, right? How long it's going to be? All those things, you start asking the question, right? So you need all of the business analysis. And then on top of that, right? Once it gets it, all of the tested in that, right? You need somebody to interact with your end customers and says, here is what we built it. You want to test it? What are you going to pay for it, right? And then it's always a financial part of it, right? How much money I'm going to invest it before I can get anything out, right? So you need a financial analyst, right? So when you build it, a project team, you need to build it all of the skills, right? Now, depending on the size of the project, the number of people with that skill required is going to vary, right? If I'm writing a big software, I may need hundreds of developers. And I may need like 10, 20 analysts, right? To analyze all those requirements and do that, right? Because one person can't do it, support 200 people. But if I'm writing a small project, right? Let's say it's a small 6 months effort for 3 to 4 developers. Most likely I need only one business analyst, right? Because he can fulfill all of those requirements, can interact with the customer at the same time, rather don't have to worry about selling, right? I may have only one project manager who only manages the project, but also manages the finances and so on. So you need all those skills. Now, when you think around, all of those people's needed it, right? And you need to do it like 3 to 4 years of investment before you can build it out product and sell to customers. It's a huge undertaking, millions of dollars, right? Do you really want to wait till the final year to figure it out? Hey, I'm not going to be competitive in the market. I can't make any money in this business, so it's not worth it doing it. Think about all of the investment, all the people that you had to pay for that. Is it worth it? Right? So you need to start thinking that way and says, what instead of that? I said, you know what, I'm gonna be very simple thing. I'm gonna just make it that I'm gonna make the first version of software only for those people who file 1040 easy, federal. I'm not gonna do everything, right? And my data shows that let's say 2% of the people do that. I can sell my software to those 2% of the people, make a money while I enhance it to add from a 1040 easy to 1040. Right? Then I can just do an itemized, right? So I can break it down my problem into different pieces and says, can I start with the smallest piece first and build on top of it and build on top of it? That's your Agile, right? You're not breaking it. What they call it a lot of times is slicing vertically problem. You're doing it end to end, right? You're not just saying, hey, I'm going to do this piece for this piece of that, then you can't sell the whole thing, right? So now you can do it, the SDLC for 1040 easy and says, what is it required? What is it? It's a simple text table, right? So you do that, maybe I can get it done in a week's time, build it and sell it, right? So typically this iterations in an Agile world is anywhere between 2 to 4 weeks, no more than 4 weeks. Okay, so you're doing it rapid development, you're understanding it. It also allows you to understand it, test the market at the same time, right? I'm selling it. Is the people picking it up? Am I making a money? Is the product viable? Right? So if you think around, right? And some of you might have looked into it, right? You keep getting ads that, hey, TurboTax, it's a free for you if you're first time users and it's not a complex for that. You can do it online. What they're doing it is started shifting the mindset of people from doing it on their machine to do it online, right? And says, hey, we don't have to write a complex things for online right away. Let's just do it for people who are doing easy because it's simple table lookup and then you can fill it out. They're doing nothing but the Agile way to do it. Okay. Then you take the second piece, right, and says, I'm going to go from 1040 to 1040 easy. Your 1040 part is already there. You just keep adding additional calculation and computations and then allow them to pick a path and says, do you want to do 1040 easy or you want to do it 1040 regular? Then now you have two paths, but even within that, you can break it down standard deduction versus itemized, right? Standard deduction is simple. You don't have to do a lot of calculations. Itemized is a lot more complex, right? And within itemized, now I have to deal with all the different, do you have stocks? Do you have a business income? Do you have business loss? Do you have a stock loss? Was it a short term? What is it long term? All of those things now starts coming into play that you can build it. Then at some point it says, okay, I'm done with the federal. There are 50 states. I don't want to write all 50 together at the same time. I can just say, we do the federal and we currently support only Ohio. So they do it for Ohio state tax. Within that, you can also go with standard, itemized, all of that. Then you pick the next state and then you pick the next state. That way, while you're building it, you're actually getting the customers who are paying the money and doing. What it requires you though is a better management in terms of requirements. Is this focus only on 1040? I don't have to worry, but I know that there are others are coming. But let's just talk about this. So when you're doing it and now let's say in the requirements within that iteration, your focus is small. You're focusing on one small part of the problem, solving it and then building it. But as you build it, then you have to start talking about how does it impact to the what we have already built it? Does it anything of those needs to be changed, or this is just an add-on, right? So your requirement starts getting a little complex as you go from iteration to iteration, because you are the one who are enabling them to visualize how things stitch it together. Okay. Any questions on how Agile development methodology works? Kaushal, Kathy, you're good online?
Yes, all good.
All right. Now let's talk about the second methodology, which is a rational unified process or RUP methodology. Okay. This is typically deployed when you're trying to build a large scale projects. Okay. So one example is if you think about, right? Nowadays, Mr. Elon Musk is in a lot more news, so everybody knows who that person is, right? But think about it, like he has another arm called SpaceX, right? They're building incrementally. His vision there is he wants to go to the Mars to build it, right? Now, when you think around building it a lot, or even Jeff Bezos, right? The Blue Origin, trying to build a similar thing. It's not a small project, it's a multi-year project, it's a complex project. Right? You can just go ahead and build it, right? Same thing, like it's the example I remember it, like it's from my old, when I was working for Air Force, is building out an F-16 fighter plane, right? It's the whole ecosystems that you do it for the fighter plane. And not all of those planes are actually like it's only the Air Force, right? The plane goes in the Navy, also sort of lands on an aircraft carrier and everything too. And then they build a whole bunch of things, right? You can't just take it on like say, hey, on day one, I'm going to land it to the Mars. You have to test out whole things. But when you launch it, at that point, you have no control. It's either going to succeed or it's going to fail. Right? So how do you mitigate all of those things? It's essentially you break it down into the phases. Right? That's where the rational unified process comes in. It's originally IBM's methodology to build a software for it. Okay. So in there, like there are 4 phases, starting from an inceptions, then goes to elaboration, then constructions and transition. Think around similar in the SDLC lifecycle, right? Inception is I'm thinking about, is the project viable? What are the requirements? Can I do some little bit modeling around those things so that I understand what my requirements are? Then you go into elaboration. It's essentially, okay, it is a feasible project. Let's go into full scale. Let's make sure we understand everything that needs to be built, how it needs to be built, how it fits in together, right? And as I do that, I'm going to do a whole bunch of analysis. I'm going to do some testing, some prototyping, connect all the pieces together. Then I'm going to get into the construction phase, where I'm going to start building it, those massive pieces together. And once it's all built, then I'm going to launch it, right? So you think around in case of Blue Origin or SpaceX, right? They want to go to the Mars. They know that they need to build really powerful things because it's not as simple as just lifting something into the low Earth orbit, right? It's taking people out of the Earth's orbit, getting out of the gravitational, but getting it enough supplies for people not only to go, but enough fuel to go and come back. When you land on Mars, it doesn't have a complex ecosystem like what's in Earth. So how are you going to get the people off the Mars and back into the space to come back to the Earth, right? So all those pieces, they need to model it out, right? So the way they do it is they tested out those engines on the ground here. They tested out in the low Earth orbit, right? Through the SpaceX system, says, can I connect it to different spacecraft? When they go to the moon, can I connect it? Moon is still far, but it's not as far as the Mars where you need to wait for 6 months to reach that, right? So, and all of those things has to worry about is, hey, what if I miss the mark? I go into infinite space. There's no way to return for me, right? So they need to model those. So if you see it into the RUP, what you're going to see it is in the inception phase, there is a heavy emphasis on the business modeling and the requirements modeling and a little bit of data analysis. Once they understand the feasibility of building a software, right? So when you think around spacecraft, right? It's essentially liftoff. Then there is going to be some human life sustainment, right? There is going to be some essentially a plumbing systems, right? So electrical systems, there's some communication systems going back and forth, right? You need to model all of them and say, is it possible, right? It's a lot more easier for people to say, hey, I pick up the phone and connects it here versus when you're millions of miles away, the distance it takes it to travel, right? the amount of power I need to send it, the strength of the signal. All of those needs to be modeled, all of those needs to be tested, right? So that's why this is a visual of like it's where most of the effort is spent, right? So if you look into the inception phase, the most of the effort is in the requirements and modeling. Little bit of analysis, a little bit of implementation, right? I'm going to try it out the prototype to see if it's going to work or not. Then you get into elaboration phase, and there could be multiple iterations within elaboration phase, right? So remember, these are multi-year, multi-months projects, right? So you're going to have a lot more frequent check-in through, hey, I tried to do it, engine, does engine works it enough to go from here to the low Earth orbit? Good. Can now that power it all the way to Mars? That's the second phase, right? So I can do an elaboration on first part of modeling works. Second part, well, I need to think about it a little bit differently. This is where you do a lot of analysis and some implementation. Then once you know that feasibly all the modeling science works as expected, then you start building it to full-fledged things, right? Then you say, hey, my launch system, all the software needed for it, the backups, right? The backup for oxygen systems. I can start building it out, the living quarter support systems. I can start building all of those software. Then at some point, I'm going to launch it, right? I'm going to launch it in space, because when I launch it, I want to make sure all of the due diligence is done before actually somebody sets into that, right? And that point, I'm going to get transition, right? In software world, transition is essentially, I'm going to go into operational world. I'm going to stay there in that operation mode for a while. But as I do it, right, my change management is important, right? Hey, I change from this to this version of software, and I do that, right? And that change management is important. Okay, it was kind of a very interesting, if you're like it's in this space things and software development. Back in early 2000, right, there was a joint venture between NASA and the European Space Agency to put something onto the Mars. Okay. Both the teams work independently, and this is where change management comes crucial. Work independently, great. One team worked on miles, other team works on kilometers. Braking system was built by the European Space Agency. They were calculating based on a kilometer. They still feel, oh, I have been fine. One was mile. Guess what? Instead of a soft landing, nicely landed at like 50 miles an hour and crushed it into that, right? That's where the importance of the business requirement comes into the play. Do you have the right validation to make sure all of the things is specified in the right unit and right parameters? Okay. So this thing, if you think about, if you look at it, right, there's a lot of upfront design. When you look into this phase as inception or elaboration, if you look at it, the majority of the analysis and design effort is concentrated in the first two phases, and not as much as into the construction phase. Versus if you look into the Agile world, it's continuous design. You're continuously evolving it, doing it. Not everything is upfront. Only vision is upfront. Everything else is there. Okay. Then the third aspect is waterfall development methodology. Okay. So in this case, if you take an SDLC and flatten it out in the line, that's what it looks like, right? The requirement analysis at the front, then there is a design, then there is coding, testing, and deployment. In this particular methodology, right? What they want to do is, I want to know the entire scope of the problem beforehand. Let's put the requirements, everything that you needed. Then we will start the design work. Then we will do it, the coding work. Okay. So think about it, if I'm building a house. You don't go along and say, oh, you start building the house, I'll tell you whether I need a 2-bedroom, 3-bedroom, I need a 2 floors, I need a 1 floor. You can't do that. Right? So you need to have majority of requirement up front. And every time you ask for any change, they say, hang on, we need to pause. We need to look at what this impact is. Do we need to redesign? Do we need to destroy something? and they build it, right? So if you just originally started and says, hey, I'm gonna have it only one floor on my house. They start building it and says, no, but it's nice to have the second floor for the kids to hang around. And oh, by the way, I want a basement also, like it's because in the winter, kids not gonna go play outside. I don't want to be bothering me on the first floor, so give them a basement so that they can play around that. What they're gonna do it. Significant change. I can't use it what I have it, I have to destroy everything and build it and do that. Right? Same thing in a software world, like it's if you just say, hey, I want to build it this way. And then you change significant requirements that says, wait a minute, I need to go back and do it. Right? So if you're building a software, the mindset that every time a new thing comes in, I need to throw it away and restart from scratch. That means I'm going to go back all the way to the start, right? So think around waterfall, right? So if you're taking the water from the bottom and put it all the way at the top, right? It has to flow through all of those steps again in order to come back down. That's what this looks like. Okay. There are still valid reasons to use the waterfall design, right? When you know that, hey, my market condition is not constantly changing. Once I build it, it's fairly stable. I know it's going to take me a time, but I'll build it. Like I need to know upfront all of those things. Still valid. Like in fact, there are a significant number of organizations still does a waterfall. A lot of times they claim they're doing Agile, but they are doing a waterfall. They want all the requirements up front and they build it incrementally, but the requirements are not changing. But in some cases, right, waterfall may not be suitable, right? The market is determining it, right? So like it's in thinking around the AI world, right? Right now, there's so much buzz in AI world, right? There's constantly requirements are changing every day. But you don't have luxury to say, hey, I'm going to scratch everything. So you need to think around adapting an Agile. How I'm building my components, can I evolve it? Right? Think around Facebooks of the world. Think around Instagram of the world, right? Things is constantly changing, even in the banking industry, right? When I went in banking, the way it traditionally was working is banks will create product, and as a consumer, you just use it. They give you whatever they give you, you don't have a choice, you use that. Right? Perfect for waterfall, right? Because they can take a time because nothing is changing. They're telling customer what to do it. Fast forward to the millennial and Gen Z, right? My kids don't go to the bank. They say everything needs to be in the phone, needs to be Venmo. And if you don't provide that capability, somebody else has provided. So I'll just go do banking with them. I don't need to banking with you. So as a banks, you have to constantly evolve it now. Your requirements are changing, but you can't throw it away, all the customers. In order to survive, you need to do that, right? So you need to adapt an Agile in that case. So there is a reason you can still do a waterfall or an Agile, right? So one of the key things is going to do it is when you get into it, a lot of companies have now started putting a standard. Either we do this or do that in order to essentially meet with the constantly changing customer needs, right? Ever since the internet world, right? The customer is king, if you started hearing that phrase, right? They are demanding what product they wanted, and if you don't provide that product somebody else is providing, they'll just go with that customer. Okay. So now when you go back into the requirements and the business analysis, right? Irrespective of which waterfall you do it. Right? If I do it in Agile, I need the business analyst constantly, right? Because I'm updating requirements, getting requirements in every cycle and do it. In this case, waterfall, most of my requirement analysis is done up front, right? So I'll need the business analyst type of resources a lot more upfront. Once that's done, I'll still need some support, but not as much, right? My need goes down a little bit as I go into the coding and integration phase compared to my design and analysis phase, right? Same thing goes in or up also, right? As I said, most of analysis and design is upfront. Once it goes in construction phase, it goes it down. So depending on the projects that you're supporting it, right? You're gonna start seeing it sometimes. The need is gonna ramp up if it's a waterfall in that. And then they tend to move the people around the project. Hey, you're done with this project, go do analysis of that. In case of Agile, right? You tend to be embedded part of the team because you're constantly doing that work in every sprint. Okay, so that's the difference depending on where you work on it. Any questions?
Like in terms of the Air Force example that you gave for the RUP, how would you define or how would you differentiate that piece with waterfall?
Okay,
Because primarily, it's just sounding like all the requirements up front, and then you're finishing step by step. So how is that step different than this step?
so think of this way, is when you do a waterfall, you're collecting everything up front,
Mhm.
right? And then you're not going and changing requirement based on what you're learning. In case of a RUP, right? So typically when you're building in an airplane, right? They start with the model, right? And they do a wind tunnel exercise first, right? And then what they learn from wind tunnel, they actually make it and they change the requirements. Right, so when they build it, stealth bomber, right? And I know a little bit of that since I was part of the working report. When they build the stealth bomber, right? They did the model analysis and said, hey, if the structure is like this, it still reflects it. The rays that comes in from the radar. Right? So that means that it can still be detected. What if I change the dimension of my angle where the radar comes into it by changing it, becoming it more circular or more angular? Then it reflects it. Does it reflect it? If it's circular, right, it reflects it back to the radar because it's constant, right? So some rays will go. But if it's angled such a way that it doesn't go back to the radar, then I have a chance that they will not detect me. Right? So my requirements evolve it as I learned it more into my modeling phase or my inception and elaboration phase, right? In case of a waterfall, that would have required to go back and change everything. It doesn't leave much room for learning and iterating it. RUP allows you some flexibility, but it still requires a lot of big upfront design, which Agile just goes in and says, think about Agile is that, hey, I'm building a small plane. That small plane, I can solve it. Now then I'm changing the shape of the plane and flying it, then selling it, and then that. So that's the difference. In case of a RUP, I'm still not shipping the product till that, right? So my aircraft still took like years to build it and send it out. But it's still constantly evolving and doing it. But there's a lot of upfront design versus all of upfront design, right? So think about waterfall is all of upfront design. And every time you change a requirement, I need to go back and redo everything. That's the difference.
It is much complex projects, right? Versus software development project. So waterfall is more popular for the software, business application software and so forth in the companies. I think the RUP is more for the aircraft systems where.
Well, it's a complex system, right? It's still software, right? So when you think around the original healthcare was built it out, that was still RUP, right? Because there's a lot of moving pieces. Right? There's a patient information, there's a lot of that. So I need to collaborate and building it together in order to do that. Right? So, any other things? Okay. So let's talk about importance of business analysis in a software development, right? So think around the life cycle. Okay. If I am trying to build something, I need to understand what is the feasibility of it, right? And in order to understand the feasibility, I may have to provide some support to get the information, right? So if you look into making an understanding is, hey, do I need to actually build a software, right? I may still need some data point in terms of how many times people are doing it. what manual processes they're using, how long it's taking all those manual processes. If I automated, what kind of things I could potentially eliminate it with automation, right? So I needed all of those analysis done in order to build a business case. Say, is it feasible or not? Right? So that's the step where they can start supporting it in building a business case, because it needs some sort of analysis, right? So think about it. Business analysis, it's nothing but somebody who has the right skills to take a big problem, help them to break it down and understand what are the complexities involved in order to deal with that problem. It's not necessarily how it needs to be solved, but what needs to be solved, what needs to be done. That analysis is crucial skill for the business analyst. Okay. So as you go through it, you do that. Typically, they help it with the planning, right? Not only just initial analysis, but as planning. Let's just build a model. And if we build it, what financial model we need to build. But once it gets into it, it's essentially getting the requirements. And the most crucial part of getting a requirements is understanding the business, talking to the users, right? Whether it's an employee or customers or partners, talking to them and really understanding it, what is the process looks like, right? Just think about it. Your business problem solution is, here is the process. Whether I don't know the process and you're helping me to define the process, or I have a process and you're helping me to automate it through the software, or augment it with some capability so that it becomes more effective process. So getting that eliciting requirements is one key skill. But if you get like it's thousand of requirement, you still need to organize it then logically, where people can make a sense out of it, right? So that analysis and organization requirement is a key skill that you will need to do it. Also, when you do all of those analysis and you hand it off to the developers, they may not understand the business speak, right? So when you talk about it and say, hey, it needs to get a reasonable response from a business point of view. Yeah, the developer says, yeah, reasonable response is good, but what is it? Is it 10 seconds? 1 second? 1 minute? 10 minutes? What is reasonable? Right? So you need to have that ability to essentially take that requirement and ability to translate it into a model or a language that the people who are implementing can understand. Right? If I'm building a house and I said, yeah, I want a 2-floor house. Great. I still need to know it. What do you want on the first floor? What do you want on the second floor? Right? What kind of amenities, what kind of abilities you want in each of the floors? That still needs to be done, right? So, but just by saying I need a 2-floor house, it's good for the business, but the developers can't say, hey, yeah, but what do you mean by 2-floor house? Right? So ability to translate that requirement and then do it on that, right? So they say, hey, I want to use it, my, let's say 2nd floor for gathering, like it's when friends comes in, I want to hang out on a loft, or the kids get out, they just want to like, it's just have a good time on it. Yeah, that's a business requirement. You need to say, okay, does that mean they're going to connect their phone to charge it there? How many plugs you need it? What else are you going to do it? They're going to dance it? Does that a lighting needs it? Right? I definitely need an air circulation. How big is it going to be? Is it going to be 1 room, or it's going to be a big floor? Or is it going to be 3 rooms and then there are 3 small sections? So all of those questions you identify in the analysis and organize it, but then you still need to convert it and say, hey, you need a 10 by 10 room with HVAC, with at least 10 plugs, with this much power and ability to connect this type of power so that people can connect it, right? Then once the communication or the requirements is understood, right, you need to make sure if there are questions, there is the ability to go back and forth and get that clarity. So there's a whole communication plan comes around. If a developer has a questions and there is no clarity, how do you go to the business? Which business user has provided it, right? There's also comes into when you go into the building a software in the real world, then it comes out something known as persona. Who is going to use it? Is it customer using it, your employees using it, or your partners are using it? Within an employee, what kind of employee? Is it a security guard? Or is it somebody who's writing a developer, or is it just normal business users? So all those things comes into your communication plan. And then when the software is built, often the business analysis starts. Excuse me. Often they are tasked to validate and say, is it behaving the way that requirements were given? If it's not, identify the defects and do it. So they also write the different scenarios, test scenarios in order to do a user acceptance testing. Okay. So the BA gets engaged into throughout entire life cycle. Depending on what development methodology are using it, they may be heavy upfront, or there may be continuous engagement. Right? Even in a waterfall, once the software is built, again, there is a heavy testing needed. Right? So you're upfront, you're involved, you low in the middle phase, and then back again in the fifth. So that is an important of that. Now, this is an eye chart, but it's based from the real data. Okay. So in early or mid-90s, there was a research and study was conducted and says, hey, there's a lot of projects coming in, a lot of them failing. So there was a analysis done over thousands of projects, which talked about exactly what caused a project to succeed and what caused it to fail. And then there's data compiled that, like it's, and if you look at it, like it's a lot of categories is, I didn't understand the requirements, or there was no user involved. So I made up what I think the user wants it and build it, right? Without really actually getting the requirements from the users. Okay. There is also constant change of requirements. They gave you and they said they change your mind of that, right? And it became to a point where your software is brittle and unsustainable to do that. Now, again, this report was done prior to the Agile world. And most of the Agile methodology came in early 2000, but it still holds true. Like even in Agile world, if you're giving it a requirements that doesn't match with your vision, and your vision is that you're going to start building it into a whole bunch of things, what they call a lot of times is a scope creep, right? You wanted to build a car management systems, but then all of a sudden you expanded it to garage management and the house management. And all of those things then now leads to a failure because now you're building so much complex software, it's very hard to manage and maintain it. Okay, so here are some of the data around just the analysis. Okay, more than half of software bugs or problems or defects that you talked about, the root cause when you start looking into it is traced down to not understanding the requirement or not collecting the specific details. Think about it. That's why it's a BA is more important, is because they are providing clarity in terms of what needs to be done. Right? Think about it, right? If I'm building a house and I didn't clearly say how I want the HVAC systems and the electrical systems to work, and I change it, hey, I want a low voltage, I want to have a dimmable lights here and that, all of those changes, requirements, I change it, they're going to end up redoing it. And the cost of redoing it is significantly higher than that, right? Same thing in a software world, right? If I find a bug and says, oh, I didn't mean this, but needed to be this. Oh, we forgot to give you this requirement. Now, some of them could be fundamental things that may require complete redesign and rewriting. That's a huge cost, right? And even if it's a small thing, I need to go fix it. Somebody has to test it, right? Then I need to redo it. All of the deployment, I need to redo planning. All of my timeline is going to shift because it's no longer available. So all of those things is more than half of that. Essentially, those fixing requirements cost about 70 to 85% of project rework cost. Same thing in the house, right? You change it anything, The contractor is gonna give you a little bit of different bill than what you expected. Right? The average project exceeds the planned time schedule by 120%. That means I was looking in 10 months, took me 12 months. Right? Now, there are repercussions on the business side for 10 months to 12 months. Right? For 2 months, I need to find alternate spaces. Cost structure around it now changes it. The benefit calculation that I have it, all of those changes it. Right? Another thing, more than half of the project cost almost double your original estimate. Right? That's when the company starts getting into the loss. Right? Think around Boeing when they were building 787. It took more than double the time that they originally planned it. It cost significantly more. And even after they deployed it, like they have to ground it multiple times to do that, right? All of those is reward cost. That's the cost they didn't expect it, right? Eats into the profit. Same thing with the software companies. If you're not mindful and your project keeps going overrun, you still have to pay the developers, right? They are your employees. It's not a fixed price. Very few companies does any fixed price software development, right? So all of those things comes into it, right? Look at the number. Only 1 out of 6 or less than a 6 gets it completed on time and a budget. And when you look into those things, goes back to having a very good discipline on understanding requirements and good discipline in terms of execution. Those are the few 1 out of 6 projects, right? And the cost essentially becomes so much that 1 out of or 3 out of every 10 projects gets completely canceled. So all the money goes in the ring. So all of these things, because we don't have the right analysis in terms of what needs to be done, right? How is the second part, but what, if you don't know what needs to be done, you can't figure it out how it needs to be done. Or if your what changes, your how it may not be valid anymore. Okay. So that's around the projects. Now think around, if I have to look at it, most of the software development and says, I want to break it down into the categories. Here are the 5 big categories that you're going to see, right? The first category is obviously is completely brand new development. It doesn't exist. I need to build it something from scratch. I'm going to do that. Okay. Second category is it exists, but I need to start enhancing it to meet the newer needs or provide additional capabilities within that. So that's an enhancement. The third category is a rewrite. There is an existing systems, but it's not sustainable. It cannot scale it to the number of users that is expected at now. Right? Or technology does not sustain. It's so old, it's brittle. I can't find the people to manage and maintain it. Therefore, it's more cheaper for me to rewrite it and decommission the old one, right? Example I was talking about, right? A lot of insurance and banking still runs on a mainframe. Not many university offers the mainframe courses. Not many people get graduated with COBOL programming or basic programming. What do you need to maintain those? COBOL and basic programming. You're not going to find it. You can find a lot of Java developers. That's what you're going to end up doing. And at some point, you have to make a decision. You need to start rewriting it into your platform. Right? In order to do that, the key thing is, it's not just simply rewriting, right? You need to know what system does it. That means you need to understand all the capabilities of the system so that you can replicate that into a different instance. Then there is a platform migration. This has been kind of one of the major themes lately. A lot of companies that what the way their data structures is going to, or their cost structure is, they build and manage and maintain their own data centers. So in other words, whether I need to use the whole systems or not, but I still need to keep it like it's kind of redundant systems, right? In case if my machine fails, you need to make sure the other one comes up in that, right? Lately, like there's a lot of, from the last 7, 8 years, it's a lot more concept of clouds, right? Amazon, AWS, must have heard about it, right? Google Cloud, Apple Cloud, right? So people are no longer putting the information on their devices or even applications on your premises. They're deploying it in the cloud. Your data is stored in the cloud, everything is there. That means I need to migrate it from an in-premise platform to a cloud platform. Right? It's not rewrite it all the time. Sometimes it's rewrite, but sometimes I can take that code, can enhance it and migrate it. But that migration requires decommissioning the old systems, moving into that new system. That means the monitoring systems that I've built it on top of it needs to be enhanced to reflect that. So those are platform migrations, right? From one hardware platform to another. Take an example, right? Windows 11 is going to be dominant, right? Windows 10 is going to be decommissioned at the end of this year. So any machines or any operating systems or platform or servers running Windows 10 needs to be upgraded to Windows 11, retested it, make sure everything still works as expected. That's a platform migration project. And the last aspect of the project you can categorize is data warehouses. Right. So essentially it's a build and enhance the systems to manage the data. Now, think about the amount of the data you collect today versus what you were collecting 10, 15 years ago, right? Pretty much everything is instrumented, everything is online, right? You collect that data, you have to store that data, you have to manage that data. Now, when you talk about AI, how many of you have heard about ChatGPT? Kushal, have you guys heard about ChatGPT?
Yes, I've used it both personally and professionally.
Right. So when you think around, ChatGPT was not around 4 years ago. There was, right? So those who actually followed the neural network, right? AI is nothing but the neural name of the neural networks. That has been kind of in around for like 40, 50 years in the system development. But all of those requires the data, right? And it's not only data, it's a right set of data, and you have to train the model on top of that data in order to give it, right? So ChatGPT has 176 billion parameters. ChatGPT 4.0, which is a professional version, and the newer version of it has almost 1 terabyte of the points. So think around all of those data comes in. Somebody has to manage, right? That's a data warehousing project. That goes into big data lake where you can actually train and model all of those AI systems, which can then be used it. And as they are used it, they're generating more data that needs to go back into the data warehouse and needs to be a feedback loop on your AI models to do that. Right. And then when you have millions of customers, think about the data points, the amount of data that you collected around those things. Right. Everything from a point you're using phone, how often you're using it, when you're traveling it, what all towers you're connecting, all of those things is data. All of that is collected and managed. How do you think it's Google predicts it, how long it's going to take you to reach from one place to another place? It's collecting everybody's data and says, okay, you were traveling on this road to this, it took you this many points and move it from this tower to that tower. That's what they calculate how long is essentially wait time, right? And that's how it turns green versus yellow versus red on the traffic lights. Data, right? Data warehousing. So that's another massive type of project. Okay. Yes, Kushal.
So taking a look at the importance of business analysts, and I see overlapping areas between business analysts and product managers. So I'm trying to understand in terms of a business analyst, do they have a higher level of scope compared to a product manager, where they're mainly focused on the business side of things rather than a hard focus on the product? Or I'm just trying to differentiate that in my mind.
So when you talk about product managers, right, they're responsible for the direction for the product.
Mm-hmm.
So let's say, I'm giving an example of ChatGPT.
Mm-hmm.
So as a product manager of ChatGPT, I may say, hey, I want to expand it to not only just include the large language model, but I want also them to be doing analysis around images. They should be able to consume the images and then get the information from that. They should be able to consume videos and get the information from that. That kind of level and decision is made by product managers. The business analyst or product analyst, right? They are like, a lot of companies use those two words synonymously, right? But think about their scope is how I'm going to consume those videos. What all type of video feeds I can consume it.
Mm-hmm.
How does that video feed converts into the text that large language model then can search through it? Is it used it only for image matching, or is it using it for image generation also? Right?
Okay.
All of those things are specific requirements. That's where product analyst or business analyst dives deeper into it.
Okay. Okay.
Product manager says, hey, I want to be able to do it text to image and image to text type of capability. Then the discussion and the analysis of what all is feasible is what the product analyst tries to get into it. And a lot of times they interact with your technologist also to say, is this feasible? Is it possible or not?
Mm-hmm.
So they have more like a strategy.
Yeah, the product manager
Okay.
strategic, also they are hold accountable for the direction of the products, also the viability of the products, also for P&L of the product, right?
Mm-hmm.
Products sustainable, right? So when you look
Okay.
into it, that's why I was kind of mentioning, right? Things is evolving into the product management, not necessarily just the project management. And it is, there's a lot of additional different type of skills. People need it. But at the end of the day, whether you call it a product or a problem or a project, right? Somebody needs to understand what exactly it is, analyze it, and identify what needs to be built based on that. That is,
Okay. That makes sense.
that's a product analyst.
That makes sense. Thank you.
So at the core of business analyst is the skills for the problem analysis, right? And there are like, it's 4 key things that you need to start thinking about when you're trying to analyze a problem, right? And you take this, I know you talked about being a mom and mom flag person. All of these things is applicable into it, right? It's not limited only to the software, right? When you're trying to deal a problem, you need to understand what is the root cause, right? What is the key problem that you're trying to address it? And in order to do that, you need to ask a lot of probing questions so that you can get away from the symptoms, get into the root cause. Okay. Then you need to think about it. Now that I understand the root cause, what is the objective? What exactly I'm trying to like it's achieve? I understand the problem. Do I want to resolve the problem? Do I need to assign it to somebody? What exactly needs to be done, right? What is the objective when you talk about the analysis of the problem? Once I understand what is the goal that I'm trying to achieve, sometimes those two lines get blurry in the business world because they're trying to achieve something, but they're not articulating in a problem way, or they articulate in problem, but they're not articulating what they want to achieve it, right? So having that skill to ask them and get those two things clarified, it's a key. Then you understand what is the drivers. What exactly is causing you to think about a solution for it? Right? You know, business world, right? Often you're going to say, it's, hey, I want to essentially increase the productivity. I want them to process more packages on a day versus, like, let's say they're doing 10 packages a day. I want them to process 20 packages a day, right? Because then that way I can deal with the business growth. I can deal with the productivity. I can reduce the overall cost, those kind of things, right? So what is the key things that's driving this problem? Okay, in the scope, and this is where most of the people get tripped. What is the scope of the problem? What exactly are you trying to do with? What exactly are you trying to build it? You're trying to do everything? Or you're trying to do it only some things? Something is still going to be done by humans, something is going to be done. What exactly is it? And that scope has to be part of your discussion in terms, because then only you can identify what is your solution space is going to be. If I don't know the scope, I don't know what my solution space is going to be. Okay. Any questions around that before I dive into real business problem? Okay. So think about any business problem that you're trying to face it from the business point of view. Okay. It broadly falls into one of these 5 categories, right? Either you're trying to look for a process improvement, you're going to look for a productivity improvement, or you're going to look for a cycle time improvement. As a business, you have to manage the cost, right? So sometimes you say, it's, hey, you know what? I'm just trying to reduce my cost. Everything else is still there. Or I'm expanding my business, so I'm going to focus on improving your market share. So let me give you an example and then walk through it, all of those 5 things. Okay. Let's say I'm a bookseller. Okay. And I have 3 stores in a city and a warehouse. Okay. So that's my setup. Okay. And people come to me to essentially buy the books. And whenever they come to the store, I go through it. And either I find the book that customer is looking for it, or I don't find the book. But I have no systems, right? Think of it this way. So, and I'm not organized. So customer come to it, I look for it, I don't have a book, I tell them, go to my other store. They may have it. So customer goes to the other store, same deal with the 3rd store, and if not, then they go to the warehouse to get that. Okay. So I'm Cleckett's looking through it, and on an average, it takes me 8 hours to go through my entire bookstore to tell a simple answer whether I have this book or not. And then they go to the other, right? So if a customer's viewpoint, it takes 32 hours to get me the answer whether you have a book or not. Okay, that's scenario. Okay. Now, if I'm a business owner of that bookshop and says, you know what I want to do it is I want to improve the process of searching the book. Okay. I want to make it sure the process is effective for searching. So one thing I may just say is, you know what? Since I want to improve the process of searching, I don't want them to go through, take it 8 hours. I want them to find it faster. Bottom line, right? Or do it in an effective way to search it. So instead of it's keeping everything into the pile, what if I kind of organize into alphabetical order by the book title? Right? So now, when a customer comes and asks for a question, my process is not to go through every book. Process is changed it, improvement to go through it. I'm going to go through alphabetical order, find that letter which it starts with, and I'm going to look only in that section. Right? I improved the process, right? I'm not saying it's going to take it 8 hours or less, right? All I'm just saying is it's the way that I'm searching it is now better. Right? If my motivation is to improve the process, that's the process improvement I'm doing it. Okay. Let's talk about the productivity. Right. So originally I said it was taking 8 hours to do that. And if I go into say, I don't want them to take 8 hours because 8 hours is a one shift. So I take a one answer I can serve only one customer. Right, in a day, in a given store. Sometimes I have to take 4 of them to get that. Because they may not be in any of the stores. So if I want to change it and say, so you know what, as an employee, I want to be able to answer 2 queries instead of 1 query in a day. That means you should be able to change the search such a way that it finishes in 4 hours. I may still do alphabetical order and then resolve that, right? The solution is still same, but my intentions are different. One was process improvement, one is productivity. What is driving me to think about the different solution? The third one is a cycle time. Originally said it takes 32 hours to find a book, right? And I'm going to think about it, customer is not going to buy a book unless it finds it. So it may take up to 32 hours to close a sale. What if I want to close that sale in only 8 hours? What would I do? Well, I may organize it. I may also put it, hey, instead of them doing a sequential search, I may just say, you know what, as soon as a customer comes in, you notify all the 4 stores and all 4 are doing the same thing. So therefore, instead of 32 hours, I'm now reduced to 8 hours. I can still be leaving it in pile, still do the same way. Or I can organize in alphabetical order and take, it's only 2 hours every store and then call it and do that and reduce it to 8 hours. The solution could be different, but my driver is reducing the cycle time so I can do a sale quickly. You see the same problem? What is the motivation that's driving it? Right? However, the next one is reducing the cost. Right. 8-hour search, let's say $10 an hour, takes an $80, right? 4 times $320 to look through a book before I can sell it, right? That's my cost, plus whatever the cost of the book is. But if I expedite it and do it in 2 hours, I can reduce that cost down to $20. In order to do that, my business problem, the way I solve it may be different. But my driver is I want to reduce the cost. Okay. And the last one is improving market share. Well, initially I'm making everybody to come to the store to get that. What if I provide a phone number so they can call it and get the same information? Even better yet, because if they call in, it could still be limited. What if I do it on the internet? Now, anybody who is outside city can also look the book, can order it, and I can ship it to them. So my market share was only for local market. Now I have to go into the whole nation. Or I could be an international, I can ship it international. Right? The solution I may implement it, the goal for that is a market share. Right? So same problem, depending on what is driving the need to solve it, could be in the different categories. Good? Any more questions? Okay. Now, let's talk a little bit about how, once you identify the business problem, how the decision is made whether you're going to build a software or not for that. Okay. Now I know this is a small, so I may not be able to read through it, but I'm going to walk you through it. Okay. And then when you get into PDF copy of the PowerPoint, you will be able to expand and see it. But think around any times in a big corporation or even in a small corporation, right? You're going to have a lot more ideas than actually what you can fund it or implement it, right? So you have to have some process to say, it's okay, we're going to do this based on this criteria, right? So a lot of times it's based on how fast I can get my return on equity, right? So ROE. And then what is the return on investment, right? What is if I invest $100, is it going to give me 110 or is it giving me $200, right? So those kind of decisions needs to make it, right? So in order to do that, right, you have to do 3 things for every project or any proposal that you do it, right? First, you need to figure out what it's going to cost you to implement, right? Does that mean I need to buy a new computer? Need to train my employees? All of those things is cost, right? Second one is time. How long it's gonna take it? It's gonna be done in a day? Is it gonna be taking me 3 months? It's gonna take me 6 months? Right? Because timeline is important, because if I'm borrowing a money to deal with the cost, I'll be paying interest. So how long it's my actual cost is not gonna be $100 that I borrowed it, but it's $100 plus 6 months of interest is what's gonna be cost for me before I can return that money, or however long it takes me to return. Right? So cost and time is two key factors. Then the third factor is, what is the return I'm getting it on the investment? Right? So let's say if I invest $100 for the cost, and incremental benefit, I get it only $100 in my profit. Is it worth it? Because I'm breaking even. I may have to cost more because I'm gonna borrow more money. And I'm putting a whole bunch of effort for no gain. Is it worth it? Right? Or I can say it's, hey, I have 2 projects. One returns 20% in 6 months. The other one returns 80% in 6 months. Which one I want to do it, right? Obviously, I'm going to do it with a higher return, right? So you have to get those 3 factors, right? So any projects that you go try to say, hey, I want to build a software, the first 3 things they're going to ask you: what is the problem I'm going to solve it? What's going to cost me? What is going to take it in terms of time wise, and how much return I'm going to get and when I'm going to get it. Right? So you take all of those things, build a business case around it and say, if you do this much, this is how it's going to cost it, and so on. And then you take it to that group or whoever is the decision maker. If it's a small company, it's easy, whoever the owner is or that, they make a decision. If it's a big company like Nationwide, Chase or that, right? There is a specific process in place which says, okay, you put in all requirements, and then will be a review board with the technology, with the business people, and with the financial people who are sitting on that board and going to make a decision. Is it worth to invest it or not? If it is worth it, they will say, it's okay, go ahead, you can have that project, we'll fund you. Right? If they need a clarity, they will ask it, okay, wait a minute. You're talking about this, but it may not make a sense. Can you reduce the scope, or can you get a little bit more insight into the cost and the time and efforts required? Go get that information and come back, right? So if I don't have that, they want to push me for further analysis, I'll go back, follow the same process to get the additional details, come back. Whether I get approved, good to go. If I get rejected, then okay, it's a great idea, but it's not feasible financially, we're not going to do that. Right? Hence that's the typical project approval process happens. And the role as a business analyst, you help them to understand the cost and timing factors.
Yeah, sometimes you put together business case as well.
Right. So. Any questions on this process approval? And that's more or less exact same in respect to where you end up going. Okay. Okay. So what we're gonna do it now. So, Marshall, are you able to,
Yeah.
Marshall, are you able to see the screen?
They should be able
Yes.
to expand as well.
Okay.
Copies.
All right. So I want you to spend about, it's 11:30 here, so let's spend 7 minutes reading through this problem. Okay. And that end of the problem, I want us to do an analysis. And remember, there's 5 problem types I've stated. What are those?
What are you trying to solve? The time, cost, return?
No. The 5 business problem identification.
Process improvement and.
Process improvement, productivity, cost.
Improve market share.
cycle time, and a
And
market
cycle
share.
time.
Right, so those are the 5 things that you need to do that. So I want you to read this problem. Understand whatever the notes you want to make it, read for 7 minutes. And what I want to do is, I want you to come to a conclusion of what is the primary business driver. Okay, there may be additional ones, right? There you might try to like think there are 3 or 4 things, but what is the primary driver for these things? Okay. That's what I want you to analyze it. Like, is this cycle time improvement, productivity, process, customer share, or cost reduction?
Understand the problem.
Understand your problem. That's what you were talking about, understanding the problem, first step. Then we'll talk objective, then we'll talk about scope, and we'll talk about others. But let's just understand the problem. This is understand problem, which type of problem I'm trying to solve it. Okay, so take time till 11:45, read through this. Make whatever notes you need to do, and we'll flip to the 5 types and talk through it. All right. You need another minute or so, or you're good with reading it? Okay. So let me try to see if I can put both of them on the same. So I'm gonna. Let me see if I can. Oh. Process. Activity. Cycle time. And market share. Okay. Let's see if I can. All of them into one place. So we need to figure out, oh, hang on, there is one here. You're right. I think some setting has changed, Herschel.
Yeah, you should be able to write it.
And that's why, otherwise I should have been able to write it. Okay. We'll figure it out, logisticals before the next class. But let's go around that.
The pen, third one.
Oh, I tried it. Doesn't,
Oh,
that pen is only like it's
Alright.
other, if I can highlight it, but I can't do anything else.
Okay.
Right? Yeah. Okay. So let's talk through this. Okay. So what do you think it is? What is the main driver?
When I was reading it, three things jumped out. One was shortening the order to fulfillment process.
Okay, cycle time.
Yeah, and the second was better managing the entire process, how they were talking about manually tracking it right now and then the
But-
number of orders.
Okay,
Increase.
but what is the primary driver? Why do they want to better manage?
Because they have a new undertaking that's coming in place.
But. So go back to what I'm saying is, don't look at the symptoms. What is the underlying root cause? That is what is gonna have your driver, right?
They want to shorten the order to fulfill.
I don't know, right? It could be better managers, like I don't have visibility, so I don't have sense around productivity. Or I may not have a process. I don't know, right? So when you read through this, which one do you think is the primary driver?
Process.
So you think it's a process improvement? All right. Okay. So you think it's a process improvement? I can give you the report. Right, so you think it's a process. What do you think, Joshli?
I think it's cycle time and process and productivity.
Which is the primary driver?
Oh.
I said that there may be multiple ones.
Mhm.
What is the primary thing that you're thinking?
Cycle time.
Okay. How about online? What do you guys think?
I think it's process because they need to like divide items into customized and non-customizable, and then they can sort it out the things according to it so that the customers can do easily view the items which is customizable or not customizable according to the number. So I think it's process.
Okay. What about you, Kushal?
I'm going to deviate from rest of the folks and say market is the driver.
All right. So if you look at it, right, we all read the same problem. We all came a different understanding. So as your business analyst, you need to start diving deeper into it, right? So we'll start doing that. So let's start with the process, right? So both you and the online say that's a process, right? So let's talk through what jumped out into this description that made you think it's a process is the key issue.
I think they're wanting to shorten the actual fulfillment process. And right now it's all over the place when they're manually tracking.
But if I want to shorten it, it's cycle time, right?
But I am thinking of different pieces to an entire cycle. Like, okay, my this is messed up. Secondly, I'm manually tracking. And third, my company
Okay.
has to take a big undertaking.
So let's talk about the things that actually made you, right? So let's say you're saying it's manually tracking is one thing.
And then
What else is that? Right, it takes this thing. Is that what you were looking?
1 to 3 weeks and going to third party vendor.
yeah, and then it says that they want to eventually improve to same day service.
All
So
right,
that means there is some process improvements that they need.
all
And
right,
lastly, it's a big undertaking that they're going to go in the future, near future.
all right. So essentially you're talking about is improving the same day services, driving you the process improvement. Am I right? Or is there anything else that you feel it's the reason why you're leaning towards process?
In my head, I think because these are all not.
These are all not, right? But there is, what is the primary driver?
That if the process is cleared and if I have a new undertaking,
Right,
I'll have more success rate versus going back and starting from.
right. But I could read it the same way, in a different way, right? It takes between 1 to 3 weeks to complete the order, right? Which they would like eventually, right? So their desire is to reduce the cycle time from 1 to 3 weeks to the same day. So I don't necessarily, I can argue it's not a process, it's a cycle time.
That is just one piece of the process, right?
Right, but what is the other process? Which process is there? Let's say, when you say it's a process improvement, let's talk what process.
Okay, so then, one is that shortening of the thing, that's a one piece of the puzzle. Second is the manual tracking, so I'm assuming they wanted it automated. Better management, like better tracking.
Right, so you think it's. This thing is essentially. Addressing it, okay,
And then when these two pieces are done, I'm more confident walking into the new thing where I have at least the basics taken care of, then I don't have to worry about my customization. And
all right. Okay. That's good. Now. You mentioned cycle time. Is that 1 to 3 weeks to the same day, it's primary driver?
Yeah.
All right. So Kushal, you mentioned different than the rest of the group and say it's a market share. Tell me what you read it and it's just driving you to think about market share.
So their overall business plan calls for continued growth, and I do agree that the highlighted areas are a part of different needs. However, their overall goal and their primary driver seems to be the overall growth and the overall sales, and the other areas are like secondary drivers. That's the thought process that I had when I was reading through it.
So. What I want you guys to think about it is. You're gonna run similar descriptions in most of the problems. And you need to start. Clearly laying it out. What is the primary driver, right? So while reading the first paragraph. You guys completely ignore the second paragraph. First paragraph is just setting up the context and the background. Think of this way. What is it saying? For upcoming season, they decided to start taking order from corporations, which they were not taking it before. Okay? To support this plan, they have decided to develop a system. So primary reason for them to build the system is to take care of the growth that they are want to do it into that. So they want to go into the market share from an individual to a corporations. Okay, so that's the market share that they want to grow it. In order to support that, they want to build a system that can do all these capabilities. All of the things that you say that is their desire. They want to do that. And they're hoping when they build the system, it'll help with all of those things too. But that is not the reason why they want to build the system. The reason why they want to build the system is they want to expand into the corporate world. So that's a market share, right? Because it's a market that they don't have today. It's a new market that they're going to get into it. So when you read the problem, right, analyze it. Is it a supporting discussions that they're getting? Or is it the primary reasons? Is this the key pain point? Because the way you think about it, right? So it takes between 1 to 3 weeks. They're just telling you what is the status today. They're telling you their desire is to be a 1 day. But then they are also throwing it to say, hey, sometimes it takes less than 2 weeks. Some are fulfilled by vendors. Some are taken care by our employee. So they're talking all the variations, which is causing that time difference from 1 to 3 weeks. Right? And they say, probably the root cause of this is we don't have a right way to manage it. So they're saying, oh, that's the problem. That's our state. But as we expand it on a corporate world, if you don't manage it, they're not going to come to it. So in order to do that, you want to be able to do online ordering. You want to be able to do it their own customization. You want to do it entire process online. So they're not saying is, hey, even with the customers and the corporate world, I'm going to be on the same day. They're saying, I wanted to have the visibility of that entire process. It's a better way to manage it. And I'm hoping as I do this, it will automatically force us to manage the other things better. But that's not the primary driver.
So again, I want to point out though here, right? So there is not a right or wrong,
Yeah.
black and white type of question. But when you justify the business case, right? ROI,
Why it's kind of
that's where I think you specify the main goal, and then you have a supplement of additional items. And a different.
That makes sense.
So, because your funding is based on, I want to expand it. Oh, by the way, when you do that, my ROI will also help with this, this, and this. So I may get only 10% uplift here. But as a side effect, I may get 5% and 2% uplift there, making it 17% instead of just 10%. Right? Okay, part of it is what I wanted you to focus is Harshal pointed out. It's not about right or wrong. It's about analyzing it, getting it and asking the right questions, right? One thing, like you all went into that, right? The first thing you would say is, okay, it's taking 1 to 3 weeks. Is that the main pain point? Tell me what is it contributing to? Tell me if you do that, are you expecting benefits? What if you don't do that? Is it going to impact on the business? When you go into that and it says, okay, if you do this, what is expecting you of that? If you don't do that, you still want to build a system? Do that? Or you're expanding the product? So getting into those nitty-gritty detail, talking with them and getting into those things is the key. Right? Any questions online? Kushal, does it make sense?
Yes, it makes sense. And when I was taking notes on the thing, is it right to I think you had mentioned it, but I just want to make sure I have it right. So need to improve market share, primary driver, upcoming season, they're offering a new area, bringing corporations. And that by improving market share, they'll then be able to contribute funding towards the secondary processes like the cycle time and need for process improvement? Or do we not even focus on those, and do we just focus on the need to improve market share?
No, so thing is that they're saying is that, hey, I cannot get into that market unless I have this capability. To get into that market, therefore I need to build these capabilities. So that is the primary driver. But then it says, when you build these capabilities, look at the other existing things that will help us with also. So they're not saying is that, hey, we are going to get into the other benefit, therefore we should build it, right? They are putting the problem as, this is a must if you want to get into this market. And we have desire to get into this market. Therefore, we are going after this. But while you're doing this, look at all this benefits is happening also, right? So for example, right, and this goes back to when you want to essentially run, right? People says, why do you want to run it? Why do you want to increase the exercise, right? Well, I want less visits to the doctor, right? Because the more I'm in the rhythm, the better I will be to them. Oh, great. I want to increase my stamina. Well, that's a side effect of it, right? I want to lose weight. That's another side effect of it. Or it may be, what is your primary driver? Like Harshal is just saying, I want to run for a marathon. Well, you're running the marathon, that's your goal. But you are gaining other benefits is that, hey, while I'm running it, I have to practice it. So therefore, I'm getting into better exercise rhythm. That helps me because I'm not sitting on the couch and not sitting watching TV. So it helps me to gain better health. It's going to force me also to make some dietary change. So I may be helping with it my other issues that I have, right? So all those things are side benefits. But the primary thing that I want to do is I want to like run in a marathon, right? And in order to run a marathon, right, I can't run that unless I practice it, I build it a rhythm, right? All of those things. That's how it comes into, right? What is the primary things? I want to like it's expand into the employee or in the corporate world. In order to expand it, I have to do all these things. I'm looking for you to build a system. Oh, by the way, when I build that system, it'll help me other things also. They're not looking to invest the money because of these things. They're looking to invest the money because of this part. And that is also going to help in this bottom. Okay. So that's the conversation you need to have, right? You're not discounting the others, but you're understanding what is the primary reasons, right? And it helps it is when you have to prioritize and you have to like it's kind of do a trade-off whether I should go with this or that. Having that understanding of the primary reasons why you're doing it, it helps it. Okay. Good with that, Kushal?
Yes, yes, that makes sense. So it's kind of all happening at the same time. I think in my mind I was breaking it apart when in reality it's all happening at the same time due to the focus on the primary driver, right?
Right.
Okay, thank you.
Just look at that. Last thing is they said they want to offer a premium service to deliver any type of order in less than a week. Right? This, if I do this, it'll automatically help me from 1 to 3 weeks to get down into less than a week. Right? Because now, hey, if I can offer for this, I can just extend it here. Okay. Okay. So let's do, right? So I'm gonna, before we stop today, we'll talk about some of the reading assignment that we're gonna do it, but I'm gonna start diving into the next module, which is gonna talk about the Agile and Scrum frameworks, right? So we talked about the Agile as one of the software development methods, right? Part of the reason you're gonna dive it into more is any practices that you apply in Agile, it's kind of extended also to waterfall and RUP, just that in Agile, you are within the short constraint of 2 to 4 weeks. Waterfall, it could last a little bit longer. Okay. So Agile framework is essentially allows you to collaborate and then do an effective way to do the things. There are two things that I want to think about, right? It's a vertical slice. It enables people to think about it, their business delivery, right? So there's always a common misunderstanding that if you go Agile, you will deliver things quickly than if you do it on waterfall. That's not the case. What it is true though, is if you go in Agile, you can deliver the business value faster than what you can deliver in the waterfall world. And those two are different, right? To deliver the entire project, it's still going to take the same time, whether you go Agile or you go to that. But from a business point of view, you can start getting things visible and in the hands of user faster than what you will do it in work. So that's the key difference. The people can start using systems earlier than what it is in there. Okay. And there are many Agile frameworks, right? You're going to see it. The most common you're going to hear is Scrum and Kanban and XP. Those are 3 commons. But as it gets into bigger organization, right? The small team is not the only team that's working, right? It's many teams are working. In order to deal with many teams, you need it's what they call it as a scaling framework. So SAFe and LS are the 2 scaling frameworks. Okay. So let's talk about Scrum, which is the most dominant framework around Agile, and that's what most of the people will use it. It's essentially, it's the key thing is it's a sustainable way to build a complex products. Okay. And that framework clearly identifies the roles, responsibilities, and the outcomes or artifacts that it gets produced. Okay. There are 3 key roles in the Scrum framework. The first one is the product owner, right? So Kushal, as you talked about the product manager, there's a lot of times people use the word synonymally product owner versus product manager. And then there is a philosophical debate about people, it's product owner is not same as a product manager. The bottom line is for most of the work and the responsibility and the roles that they played, they are same. Mm-hmm. Scrum Master is the second role, which you think about is a facilitator or enabler of synchronization among the members and the product owners. So they play a role of a glue or a servant leader within that. And then you have a Scrum team. Okay. There used to be people will talk about earlier as a development team, but then this framework started getting applied in non-software development also, so they changed the word Scrum team. But it's essentially, it's your developers, it's your testers, it's the people who are putting things into production. Okay. And the 3 artifacts that are associated with it is product backlog, sprint backlog, and increment. Product backlog is essentially everything that I want to start building in this product. Sprint backlog is in this iteration, what is my focus? Okay, and product increment is at the end of sprint, this is what I will produce it. So going back to our text example, right? I want to build a text software that does everything state and federal is my product backlog. I'll keep putting everything into that. Whether it's 1040 or 1040 easy or 1040 itemized, all of those requirement goes into my product backlog. In my sprint backlog, if I'm doing it simple 1040 easy, my sprint backlog will have only those things that talks about the 1040 easy. It says, this is my current focus. I know the whole big vision, I'll keep capturing information, but right now I'm focused only on this. My deliver and increment is at the end of the first iteration, I'm going to give you a software that enables somebody to file a 1040 easy. That's my increment. Okay. Now, let's talk about what each of the role does. The product owner. The product owner is responsible to maximize the value of the product. And they make a decision when it's a good time to do what iteration to add the value, right? They are also responsible for making sure development team has the right sets of work to focus on, right? 1040 easy in the given sprint. They're responsible for overall management of product backlog and prioritization, what goes in when, where it goes in. They're also responsible for ordering the product backlog items, right? So what is number one? What is number two? What is number three? What is number four? They will order that. That gives clarity to the Scrum team, what they need to focus on building it. What is the first important thing? Then once it's done, what is the next thing? Then what is the next thing? Okay. And then they're responsible also to providing clarity about that. Okay. So when you look back into the Scrum team, okay. So I'm going to get into this first, and then I'll go back to the Scrum Master. Okay. So when you look into the Scrum team has all the needed skill to deliver on their product. And your business analyst or product analyst is one of the skills you will need it in order to do that. Your product owner is defining it. Hey, I need to build a tech software. But somebody from Scrum team needs to ask them a question, says, okay, great. What does it mean? Is it for this year? How are you going to address it if the laws changes it? Right? Is it based on an income table? Can you validate that this is the income table we should be using it? How do we factor in if there are multiple members into the family? How do we do this? How do we do that? All of those questions and clarifications comes from a Scrum team to product owner. Product owner answers them. But then you need to have a skill to ask the right questions, right? That's why you're part of this team, okay? It is, when you look at the Scrum team, they're responsible for managing their own work. Nobody's telling them, oh, do this in the morning, do this in the afternoon, right? This is what we need to do. This is my sprint backlog. It is let's say it's a 3-week sprint. This is how we're going to organize the work. This is how we're going to do it. This is the point where we need the information. Okay. Again, the key thing is it's a cross-functional team with all of the skills needed to build a product, including the development, testing, analysis, all skills. Okay. They're responsible to execute against the sprint backlog, right? Product owner keeps things in the product backlog. They're not worried about how big the product backlog is. That's a product owner's headache. All they worry about is what is the next sprint it's going to include. Let's make sure we understand what needs to be done. What is the outcome? What is the expected goals on that? And typically it's 3 to 9 members. Okay. Some teams are bigger, some teams are smaller, but that's the rough size. And there is a science behind the 9 number, right? Is the level of one-to-one and collaboration, communication needed, it gets increased by N factor every time you add a member. Human mind cannot do it with more than 9 members. What you will see in the behavior is if there are more than those, we tend to gravitate into forming a sub teams and breaking into the groups and start doing it. So it's not a single unit at that point. And anytime you do it less than 3, you don't need a team. It's an individuals. Okay. Scrum Master. What is the role of Scrum Master, right? So think about their servant leader. They're there to make sure people understand what the Scrum practices are and they follow it. Okay. They help it, any collaboration or coordination or blockers that happens within the team that goes outside the team. Okay, let's say if I have a developer team, they're sitting and waiting some information and they say, hey, the product owner says, go read it, the IRS publication XYZ, and that publication is not accessible, right? Development team can't do anything. That's where Scrum Master comes in and says, okay, what are the different ways we can solve this problem? Help them to understand that, encourage with a different solution to get that thing in there. It serves both product owner to manage the product backlog, helps them to say it's asking rightful question. Is this good for this sprint or is it that for the next sprint? Can we organize if they can do everything into one sprint? What are the things that you wanted? In what order you want it? Those kind of things that they help it, the product owner. Okay. And then also like it's kind of do the organizational coaching. So, okay. So this is a nice visual. I like it. That gives you the entire Scrum framework into a picture. Okay. So if you look at it here, right? You have a product owner, right? On top of the screen. I don't know if I can still do it here or not. Oh, good. So if you think about it, that's your product owner. That's the role. Okay. This is the other role. Scrum Master. And here is your Scrum team. These are the 3 roles. Okay. We talked about product owner manages the product backlog. Right? And it's order 1 to N. A subsection of that is part of a sprint backlog. And then we are done it to create the finished work. Okay. How do they work? Okay. So product owner prioritizes everything that goes in the backlog. The Scrum Master work with them to help them to make that 1 to N determination. The team at the start of the sprint look at it and says, what work we can do it in this sprint? What is our capacity? Okay. Based on that, they look at the few things. They talk with the product owner and bring that into the sprint backlog. Okay. And it's not always the top 3 things. It could be 1, 2, and 4, because 3 is too big. That along with 1 and 2, we can't deliver it. So they said, okay, if it's not, what else next you can deliver, right? Based on that, then the team gathers together and says, now that we know that we have to solve these 3 problems, we know what needs to be done. Let's talk about how we will do it. They break it down that into small tasks. Hey, somebody needs to build a user interface where a user will log in to do that 1040 easy. Then somebody needs to, like, it's kind of take that table from publication, make it into this. Somebody needs to write a formula that takes it based on income, based on a table, looks up and says, what is your tax? Right? And then somebody will give them an ability to, like it says, how do I electronically sign those things or print this? Right? So you take that task, break it into multiple pieces, and says, this is what it's going to be done. Then they can divide it or they can collaborate and says, hey, 2 of you go work in this task. 1 of us will work this. I will do this. Right? So they do their task breakdown. They work on it. Every 24 hours, they meet for what is known as a daily scrum. When they meet it, they talk about it. What did I accomplish it? Did I have any roadblock? Where do I need a help? What I'm gonna plan for the next 24 hours. So there is continuous collaboration and transparency. So you're not waiting until end of sprint to say, hey, I'm blocked here. I need this help now, right? So that is what is kind of like it's happens throughout that 1 to 4 week window or whatever the sprint length is. Okay. And then as a Scrum Master, you actually look into the metrics and says, are we tracking it in the right trajectory to get this work done at the end of the sprint? If not, what do we need to do it to correct the actions? And it could be is, hey, we can't get everything done. We thought it was simple, it is complex. We need to have negotiation. We are not going to be able to do all three things. We can do this too. Let's have a discussion. Let's make sure that is what is visible, right? But you're not waiting till the end to tell it, hey, you know what? Think about it. If you're moving in a house, they give you a date and says your house will be built by that date. You show up on that date and says, it's going to take another 4 months. They better tell you, hey, we are not on track. It's going to be delayed so that it doesn't come surprise at the last time. At the end of the sprint, then you just say, hey, here is all the work. Let's review it. Let's make sure it is doing what it's expecting. Can we ready to sell it? Then you sell it. Or ship it into production environment, whatever the appropriate step is. Then you get together and say, how did we do? Did we learn anything? Should we do it anything differently the next time go around? Oh, we had so many blocks because we didn't understand this type of requirement. Can we make sure the next time somebody gives that requirement, we ask all those questions up front so we have a better understanding of what needs to be done instead of getting stuck into the sprint, right? That's kind of retrospective, right? You do that. So this is the entire Scrum framework in a picture for you. Okay. So let's talk about it, right? So what are the events? Sprint planning, you saw it in the picture. Daily Scrum, sprint review, sprint retrospective, right? Those are the key things. But while you're working on the current iteration, you also need to refine what is my next iteration is going to look like. So that I don't finish the work and then wait for a week to understand what is the next increment is. So every time I'm going to spend a little time on every week to gather that so that when this sprint ends it, I'm ready for the next sprint. So there's continuous development happening. Now, what happens in each one of the event? Who all are participants, right? So in the sprint planning, you have your product owner, your Scrum Master, and development team, right? So you will hear about Three Amigos or Triad. That's everybody is in the planning together to understand what we're going to build. This happens at the start of the sprint, right? For the next sprint, which could be, let's say, for next 2 weeks, right? This is what we're going to do it. Everybody understand? Is there a question? Is there a clarity? What do you need it? Right? If once we have it, let's talk about how we're going to task it out. How are we going to break it down? Right? So you break it down, and this is roughly, it takes about 4 hours for a 2-week sprint. If it's a 4-week sprint, it takes about 8 hours. So it's roughly about 2 hours per week or fourth of time that you're planning. Okay. The whole purpose is making sure you understand what is the priority, making sure there's a clarity of what needs to be built, and you collectively estimate, can we do this much, whatever you're asking in this 2 weeks? If we can, let's have a discussion. What can we do it in 2 weeks? How are we going to adjust the priority? What should we be focusing on? Okay. And then whatever the outcome of that planning becomes part of your sprint backlog. And that's when you start working on it. The daily Scrum, a lot of times it used to call a daily stand-up before. And then there was somebody said sensitive, not everybody can stand up. So it becomes a daily Scrum. It's essentially typically at the start of the day, right? Now with the global teams working it, some maybe working India, some maybe working UK. The team figures out what is the best time to get together. It could be at the start of the day for some. It could be end of the day for some. right? But it's the same time where everybody meets it. And it's typically 15 minutes. It's not a problem-solving meeting. It essentially trying to understand it. 3 questions. What did I just finish yesterday? So what is the progress? Can somebody leverage whatever work I did it to finish their work? What will I work on today? So people have an understand, they can adjust their planning. Hey, if you're working on this today, it will be done. So let me plan for this tomorrow. And then am I blocked on anything? I couldn't make a progress because I couldn't get this thing. Well, let's note it. Let's figure it out later. How are we going to resolve this problem? Okay. And it's essentially an accountability aspect is what we are driving it through the daily scrum. Any questions on the daily scrum? Okay. Then the next one is a review, right? And this typically happens towards the end of the sprint. And it's usually about an hour to 30 minutes, depending on the type of the work. The whole purpose of that is to actually show the real work that was completed during the sprint. It's not about talking, hey, I want to do this or I did that. Show me the working software. That is the intent. Okay. So it is kind of like it's doing a formal structure. It shows the fully demonstrable product increment and shows that what is ready to go and what is not ready to go. What this also does it is once they know how did this thing go, it may reflect it back into the product. Oh, we couldn't do this. We had to change this. Well, does that change anything in my product backlog that I need to shift it, right? So those kind of conversations still happens into here. Okay. Then the last one is a sprint retrospective. This happens during the sprint. That's part of the sprint. And it happens at the end of sprint. Typically, it happens after you finish the review because you will learn things from review. What was the effect from the stakeholder and the product owners to do that? And typically, even though it says that it's product owner, in some cases, it's only the Scrum team and the Scrum Master which participated because they may want to talk about, hey, product owner didn't give us the right requirements. So that's why we were stuck into this. They didn't give us the right priority. If they were given right priority in sequence that this must be done before this, we would not have been blocked. Those kind of discussions happen. But it's about the rapid feedback, right? You went for 2 weeks. What did you learn? Can you adjust any of the things that you go in the next 2 weeks and do them? Right? So it's about continuous planning and continuous improvement aspects. And then there is a activity which they call product backlog refinement, which is not technically part of the 5 events in the Scrum, but this is a must that you continuously do throughout the sprint. And the purpose of that is before the next sprint begins, understand what work can be brought into the next sprint. Is there a clarity in terms of what needs to be done? Is there a requirement? And a lot of times, some of your requirements comes from your SMEs. So SMEs also participate into this meeting along with stakeholders and your product owner and your Scrum team. Okay. It talks about the external dependencies, what is available, what's not available, when that will be available. So it's around sequences, right? It also helps you to flush out your requirements. So this is where business analyst plays a crucial role. Asking the right question. When they say, hey, I want to build this software. Well, let's talk through it. What is the requirement? How many users are going to use it? Do I need to build it in a scalable model? Or can I just do it on a one computer and it'll work? What is the goal, right? So those kind of things that you're still asking, it's all of those things happen in the product backlog refinement. And while you're building it, if you get stuck, that's when you go for clarification. But all of the analysis, organization, you do it in this particular event. Okay. Any questions?
So usually when the BA is asking questions, does it have to necessarily be in that time frame, 60 to 120 minutes? Say, for example, if a BA takes
That's
some
the
information.
typically focused meetings, right? Where you're getting a lot of those things done. it's not the only time where you will ask those questions, right?
If you have any follow-up questions, you can always.
You can always ask follow-up questions, right? The purpose for having this concerted meeting is where your developers are also there, right? So a lot of times you hear it, but you may not get the technical sense of how it's done, right? So developers are thinking around technicals, right? So they will ask it, what if we do this instead of that?
Oh, then you're a liaison, you take that.
Right. But this one is kind of, everybody's in there, right? So the meeting becomes more effective because the decision's happening right there rather than going back and forth, right? Because every time you do back and forth, you're losing the, right? But that doesn't mean this is the only time you ask it, right? There are still questions that, hey, we understand it, but then we say it's the subject matter expert said, let me go find that for you and I'll send you an example. That's a completely fine, right? Because then you're getting that example, you're analyzing and says, hey, I didn't understand it. Do you have 10 minutes to get together and talk about it? That's a different thing. That always happens. Any questions around how the framework works? And what is the key things that they do it in order to make that framework work? Okay. If not, I think this is a good point to pause for the day. You want to talk about any of the homework?
Yes, yeah.
So you want to talk?
That document, maybe we can talk through that.
Yeah. Which one you want, the PHN
Yeah, PHN proposal,
or this one?
yeah.
All right. All right. So the key things. So you all should have access to the proposal document, right? So this is the BC image or healthcare related applications for which there is a proposal, right? So just like I gave you a very brief one-page version of the custom creations, right? You need to think about reading through this also. Understand it is what is the problem they're trying to solve it? What is the key drivers? Remember, there's going to be like 5 types of project, right? We talked about new development, enhancements, replatforming, migration, and then data warehouse, right? Thinking on what kind of this problem is, what kind of development you're going to do it, what is driving it, right? So read through these things. Ask questions, anything that you don't understand it on Thursday, right? And it's what, it's about like 5-6 pages, but 11 pages.
11 pages.
11 pages.
So,
right?
Sure.
So read through this. Understand
yeah,
it.
understand what problem
What is-
they are trying to solve as well, so.
So think around this way, right? So in a typical world, right? The businesses will float this proposal, so request for proposal, RFPs, right? Which will have, here is what we're trying to do. Are you interested? Tell us what things you will do it, right? So this is where the cost estimate, you may look through this proposal. A lot of times, if you're involved into this as a business analyst, you will look through it and you will ask them, okay, we need to know this information, we need clarity in this. So you will go with sets of questions that you send it back to the proposal issuer and says, can you help us elaborate on the answer for this so that we can essentially estimate what it'll take us and how long it'll take us to put your proposal for you. That's what this thing is. Okay, so understand it. This is a problem statement. Understand what type of systems they want to build it. What are the underlying issues they're trying to solve it? And then let's talk through it, what questions you have it on Thursday.
Sure.
Okay.
Yep.
And then as we go through it, next week, when we start doing some of the activities, what you will also have to do it is along this project, you need to start doing some of those activities behind the scenes for you. So think about this is your capstone project. We will do some project, custom creation will continue to show an example throughout the course. We may give you some homework on custom creations too, as we go through it. But this is the project. You don't want to wait till last. We wanted to give you a preview. All right?
Okay. And I'll also send out business case example as well, so you can look through it, how they built it typically. Business creates a problem with the ROI information and stuff. So that will give you good insight on
Yeah.
what goes in the business case, because that's very important as well for you guys to understand.
Any questions?
So this is a project and we have to find like what type of project it is and then.
Yeah, just
Primary.
think
driver,
around
how-
everything that you learned today.
Mhm. Okay,
This is the capstone project. How would you apply today's learning into this?
okay.
What kind of questions you have?
Yeah, what they are trying to do, because you need to understand, just looking, because they're gonna hand you over documents, okay? They're not gonna say, oh, please come sit down or anything. Say, this is the proposal, and see what questions you have or anything like that. So come up with a question as well if you don't understand certain things. But main thing is, goal is to understand the problem, what they are trying to do. Based on
And
the,
think around, right? We had just only half a page. We initially interpreted things differently.
Yeah.
As we started talking and asking questions, we got clarity in terms of what really is they're gonna look after. Same thing applies here. Read it, the more the questions you have it, the more the clarity you're gonna have it of what really needs to be.
yeah, and this is only one document. I mean, there are, in the real life, you will have 50 documents to analyze through. So when you have another 10 or 15 documents related to the project, so this is just a beginning, yeah.
Yeah.
But we're gonna dive a lot deeper, because there's a lot more things in the business side.
It's again,
But
we're
this is
gonna
first step.
think of it, it's the process that we are walking you through it. Right? And then as you do it, we'll do an example in the class.
Yeah.
It's your opportunity to apply that process to this and learn from it. Yes, Kushal?
Are we going to get this proposal emailed to us, or will it be dropped in the Google Drive?
Yeah, it is on the Google Drive. If you go to the BCMH.
Mhm. I wasn't able to find it there. I see like the brochures, I see the
Okay, so
other
it's not,
materials, but
I'll upload it right now.
So here you'll upload.
okay.
Yep.
All right, thank you.
There in the BCMS folder. Yep, and I sent everybody access to the Google Drive as well, so
You
you
have?
should have, yeah, already sent you guys. So you should have access to all these
So that
documents.
should be in addition to your first email that you sent, or would that be a part of it?
No, it's an addition, so you should have received email from the Google Drive. If not, just text me and I will reshare, basically.
I think you would.
Yeah, I think all of you have Gmail accounts, so it's a lot easier
Yes.
to share.
Because I don't see it on my phone. Okay, I got it.
Yeah, you
Yes.
should have it, yes, yep.
Yeah,
And,
like it's easiest way is if you go into your Google Drive and see what is shared with you,
Yeah.
it'll pop up as a shared thing.
Perfect.
Yeah. And it will be under BCMH
Yes.
folder, so this proposal will be there, okay?
Yeah, and all of the content slides that we talked about should also
I
be
will
linked in the
put
Google
it
Drive.
there.
So you can do that.
But slides are just slides. I think there will be a lot more discussions and a lot more notes and everything. That's what we focus on. The project or what you produce, right? That's what.
The other thing gonna happen is we have recorded the session, right? And I think, let me pause.
And
Stop
we'll
the
upload it by
recording.
tomorrow. So you
Once
should have access.
it's recorded, right?